Hello there and welcome. My name is Nehemiah, and today we are going to build a very powerful house price prediction system from the very scratch. We'll be using machine learning, and then for the graphical user interface on the backend server side, we'll be using Django, and then on the front end, we'll be using React. We'll be using the React. Now, basically, what we are going to build here is an intelligent system that's going to predict the house price based on the property features using the machine learning algorithm trained on the raw data set, about 10,000 related records, of which this is just synthetic data I generated with NumPy and Pandas. But then I will show you also how you can get the ready data set from Kaggle for testing, for just practicing. But also this data set that I'm using, I will also share with you so that if you want to replicate what I'm doing here, you can as well do that. Basically, this is the tech stack for the project we're going to work on. On the machine learning, first of all, we require Python is the core technology for machine learning. I shall be using scikit-learn, that's for the machine learning now models algorithms. And then, of course, we will require pandas and NumPy to work with the data sets. And then the random forest for ensemble learning, then the gradient boosting as well. And then our pickle is serialization, like the model that we will have trained, we will need to save it somewhere so that we can just use it instead of like a retraining every time someone wants to predict. So serialization is like you're trying to save that model so that it can be used next time without like running the entire training life cycle. And then on the back end, of course, we'll be using the Django REST framework for the API, Django framework for the backend, and then REST framework for the APIs. And of course, there are some other things that we are going to use, like the cross-origin resource sharing headers. The database actually is just a very simple one. It is on the development. We shall use the SQLite. But then remember, the same thing, you can be able to migrate it to any powerful database system like a MySQL, PostgreSQL, and so forth. And then, of course, we shall serialize the models and then be able to share those API endpoints so that the front end may be able to consume it. Then the React, of course, will be the front end will be using the React for the graphical user interface, and then a Tailwind CSS for styling. Then the Axios, this is for client side requests, and then React hooks as well. There we shall also use some React icons, and also we shall make sure that the system is very, very responsive. Now, what you're going to learn in this project, in this project that we are going to work together, you learn how to access the data sets, handle the missing values, feature scalings, and then also you shall learn the model development, how to train multiple algorithms, evaluate performance, prevent overfitting is a situation where you're trying to feed the model with unnecessary information that will not require it to use for predicting the future stuff. Let's say you want to know maybe there's a cow, you're training the baby to know there's a cow, and she is a very, very young person. Then you want to go again inner, for example, to the inner components like the genetic components, the type of stomachs it has, and many other internal stuff. So those things, they are quite important, but then for that maybe baby, it is unnecessary. So we'll be handling that also on model deployment, and then also the model evaluation. We'll be using the R squared, root mean squared error, mean absolute error metrics to assess the model accuracy. And then for the model deployment, basically we'll serialize the models with the pickle so that we can have it saved, and then we shall load it on the production environment. Then our backend, we shall be using the REST APIs, and then and also it's going to also handle the request from the client side, and also we shall integrate it with the model that we will have built. And then at the front end, as we said, we'll be using now the React for the responsive UIs, and also matter state management, and also how to consume the backend APIs. Now, mostly the system architecture, the client side will be making the request through the API, and then now it will go to the machine learning models in the backend as well, like a trend somewhere, and then now it will be returning the prediction. So like the user will be entering the property details, then the data will be sent to the Django APIs, and then now it will be using the featured scale and also processed everything. We shall implement the machine learning service there in the backend, and then also the model now will be able to make the prediction, then to return out to the response to the user through the HTTP protocol. We'll talk about that one as well. And guys, mostly we usually provide these free courses, free tech stuff. But then if you wish to support us, we will highly appreciate the M-Pesa number. If you want to support us, it is here, 07 96 79 28. The till number, it is 4986 98 which it will return NEHMTECH Innovations Limited for the till number. Now this is very optional for those who wish to support us. Remember, we usually put some efforts on these stuff to create you good content. We are not going to monetize these courses, but then if you just wish to support us, then I will highly appreciate that. Now, before we start, I just want to give you a final product on what we are going to build before we start the project. Now, first of all, before that, I want to show you where we are going to get the datasets in a moment. I'm going to show you where we are going to get these datasets for testing. But then, these are very simple system on the front end. Remember, the core stuff, the core thing is on training the model. So the UI is just very easy. This one will not take more time. But then let's assume that we want to predict something. Let's say the square feet maybe is let's say 2000. These are property detail. 2000, maybe it is a 2-bedroom. There's a 1 bathroom. The years, maybe it is 8 years old. Now remember, the older it is, it should be lower. Actually, the old houses are always priced low, but then the latest one, the modern house, are usually expensive. So maybe let's say there's no garage there. We will be expecting some low results there. Then, for example, the square feet, maybe we can say 1,000 square feet. Then there's no floor, 0. Crime rate, school rating, maybe we say 7. And then the distance to the city also should contribute to the pricing for those who are living in the suburbs. Then they should be, it shouldn't be that very expensive as compared to those who are in the city already. But then let's say, for example, 5 distance to the city, and then the neighborhood scale and stuff. And then we can be able to select if there are amenities like a pool, fireplace, renovated and stuff. So once you do that, then of course, the floor, this is just one floor, and then you can see it's going to give you the results, and of course it's going to also show you the confidence, like the accuracy of the model, the confidence. Then it's going to give you some summary. Now if you're going to change this one to maybe 4, and then maybe also 3, and then maybe you say 5 years, or maybe even 2, and then a garage, maybe let's say it is 5, and then here maybe square feet is 5,000, and then number of floors, let's say it is 6. Then school rating, maybe we give it 10. Then the distance to the city, maybe we give it the way it is. So this one, it should give you more results. Sorry. Okay, let me try to use, for example, 4 floors, and then when I predict, you can see now this one, the price has increased based on the features that we have implemented. Now remember, the UI is not really that thing. Our focus mostly is going to build now the ML system. We're going to train the machine learning, and then now the graphical user interface, you can be able to design it the way you wish. But then now the core focus, or maybe our focus mostly will be on the training the machine learning model. And guys, the data set here, it is, I said we are using 10,000, but then now for the training set we used 80 8,000. Remember, you need to preserve some fuel for testing the model, so that you can be confident that the model is ready, or maybe to evaluate the model performance. That's why we retained 2,000 for testing. And then now, guys, I said these are synthetic data, which I generated with NumPy, random, and pandas. But then you can get now the real data sets from Kaggle. Go there and then just search. Okay, like let me show you how you can access it. Go to Kaggle. Just search Kaggle datasets. Kaggle datasets. Kaggle datasets, and then it will show you the list, the datasets button. Just go to www.kaggle.com, then dataset, or just click on the datasets here, and then it's going to take you to the dataset section. And then here, maybe let's say you're interested in, like we are trying to build a house prediction system, so you can just search for house prices, and then it's going to list you a bunch of houses. So you're going to just look for the relevant data sets that you can try to use, like house prices or whatever. Just get any data sets, and then once you have it, then you can be able to go through all the processes that I'm going to demonstrate to you, from the loading the data sets to EDA, analyzing the data sets, all the way to visualization, and then all the way to training the model. So first of all, if you want to build such a system, you need to start very very simple. It's just start by defining where, for example, the project is going to be placed for easy access. Like for me, I'm going to place it at the desktop folder, then a YouTube videos, YouTube courses, and then I'm going to create a folder. I can call it house price prediction, a house price prediction system. And then within it, I'm going to create a folder where I'm going to say, for example, train and test the model. So let me say train and test. So this is where I'm going to have, for example, folders. Okay, I'm going to train the models and the data sets and everything on this file. Now I have a data set here. I said that I generated earlier. But then I will share it. I will show you later at the end of the video. If I will forget, you can just remind me in the comment section. Then I will show you how you can access the data sets. Let me try to open it first. As you can see, it is it's around 10,000 record exactly, and then yeah, and then yeah, so that's what we are going to mostly use. So I'm going to go to where we have created the folder, and then I'm going to place it within the same directory. Like I want to place every related stuff, related stuff on the same file. So this way I'm going to place it. And then guys, we said the core technology that we are going to use for this, for training, especially for machine learning, it will be Python. So you need to confirm first that you have Python in your system. How do you confirm that? You can go to the CLI and then just search for command prompt. Sorry, you can go to the CLI and then okay, like you can just go to the system search and then search for command prompt or any other terminal. It doesn't have to be CMD. Could be, for example, terminal. Let's say you're using the Mac, you're using the Linux. Just go to the terminal and then search for that terminal. Search for that CLI. For me, I'm going to use this command prompt. Then I can type the Python -- version, and then it's going to list for me the version. And then so it means I have Python. If it will give you an error, it means that you do not have Python. So how do you go from there? You can go to the site and then search for like you can go to the browser and then search for python.org, python.org, and then go to the downloads tab, and then you can download this as standalone installer. This one, just download it, and then when you are installing, it is going to give you like some checkbox. If you want to, it's going to give you a checkbox if you can add it to the path. Make sure that you have checked that one so that Python can be accessed at the system level or the global level, because it will be like in the system environment variable. So make sure that that checkbox is checked, then start the installation. Now for me, you saw I already have it. I already have Python and the earlier version, so I'm not going to install it this one again, because I already have Python. So once you have Python, then it means that we are good. Now the other thing that we are going to use to require on this one, we are going to require the code editor, or maybe the IDE, where we are going to write our code, and mostly on the data science to train the model and stuff. The best one is going to be Notebook, because you can be able to nicely visualize the graphs, and also you can go step by step, cells by cell. Yeah, so that's very key. So we are going to require a notebook. You can use the collab.research.google.com, collab.research.google.com, and then I create here a new notebook. Create a new notebook. So this one you are not going to even require Python, because it's going to come with Python, so you'll be writing the code there. But for me, I'm going to demonstrate how you can be able to have the notebook on your system. If you do not want to install it, you can use the web version, but then if you want to install it to your computer, you can use the CLI, and then type there pip install notebook, and then it's going to install in your system. Yeah, so for me, I had it before, and then you can navigate where the project is. So if you are on command prompt, you can use dir on Windows, but then if you are on different operating system like Mac or Linux, you can use the ls just to know the folders that are there. So now mine, I place it in the desktop folder, so I can use the command change directory cd, then desktop, this navigate there. Again, I'm going to use dir to see the folders that are there. If you're in different operating system, use ls. So this is YouTube courses, so I'm going to say cd. Then since it's a multi-word, you want to make sure that you're writing in quotes. So I'm going to say YouTube courses. And then again, I can use CLS to clear, and then I can use dir to list the directories there. So here we have a house prediction system there. We have the house prediction system, prediction system. So I'm going to navigate there in quote, because it's a multi-word. I'm going to say house prediction, house price here, prediction, and then I'll be there. Then again, you can use dir or ls to show you the folder that are there. So here it is train and test. So cd to train and test the model, and then once you are there, you can type there a Python 3 or a Python 3 or Python then -m. This is a command to get where Python is located. Then you can just type there Jupyter notebook, then it's going to open the Jupyter notebook on your browser, default browser. It's going to open the Jupyter notebook on your default browser, and then giving it a moment. Then maybe I can create here a new notebook by clicking on the new, then a notebook, and then I can say perhaps model. Let me just call it model training and testing. We are going to train the model and test on this notebook. And then here you can begin now to type your Python. Okay, we are going to discuss some other dependencies that we are going to require. So like this one is now a Python IDE. We are going to use it especially for data science stuff. But then if you do not want to do this, just use the online version. This one you do not need to install even Python. I don't need to install notebook. It's already an online version, so you can give it a name. You can say, for example, Python, or the same name, or just say, for example, model training training and testing testing, and then you'll be good to go. And then you can begin now to type your you can try to test if it's working. So if it's going to execute something, it means that it is ready. If it's going to give you, for example, a value like 100 or whatever, it means that it is ready. Yeah, so it means that this one, and you will be allocated some memory, free memory there. You can see 12 GB and then 107 GB of this space free. But you need to make sure that you are having a Google account there signed in. But for me, I'm going to focus on this one. For me, I'm going to focus on this notebook. I'm going to focus. So let me try to clear everything so that it cannot be complicated. So now, the other thing you are going to require later I will show you we are going to require the Visual Studio Code. But then now for the start, let's just use the notebook just to train everything to make sure that everything is ready. And then once we have trained the model, then I will proceed to the next step of configuring now the app, the graphical user interface from the very backend to the front end. We're going to require other data science dependencies. So we are going to install pandas. Pandas is a data manipulation library to work with datasets. We'll require also NumPy. NumPy will be using it for mathematical computing and just working with the arrays. And then also we shall require matplotlib for visualization. Matplotlib, of which we shall be using a submodule called pyplot for visualization. And then also we are going to require also Seaborn still for visualization, Seaborn library. And then we shall also require the sklearn, of which when you install it, it is scikit-learn when you install it, but then the usage is sklearn. And then we are going to also require Pico library for serialization, but this one, it comes with Python, you don't need to install. So you can go to the CLI and then type there pip install, and then say pandas, numpy, matplotlib, Seaborn library, then scikit-learn. So I'm going to copy this one. Then I'll go to the CLI, and then command prompt, then I'll type there pip install these dependencies, and then it's going to install them in your system. Now for me, I had it, that's why it's telling me the requirements already satisfied. So I want to install all these I want to import all these dependencies such that when we start, we don't need to install any other thing. So we can import pandas as an alias PD for pandas. We can also import numpy as an alias np. We shall also import matplotlib. But then we say we shall be using the submodule called pyplot as an alias plt. And then of course we are going to also require Seaborn library, Seaborn as an alias SNS. And then we shall also import some of the machine learning algorithm from the sklearn. So I'm going to say from the sklearn This is a scikit-learn library, scikit-learn. So from the sklearn package, and then there is a module called model selection. Model selection. We are going to import. Import the. We'll need to split this dataset because you can see it's only one dataset. So we can split partly into training the model and then partly into testing the model. So we're going to import the algorithm that's going to help on that, which is train underscore test underscore split. Also, we are going to require to standardize, as you can tell, these data are of different scales. You can see the data are of different scale. Like we have those that are in tens, we have those that are in tens. Okay, ones, tens. We have others which are even in thousands and all that. So we need to have a scale that is going to make everything to be like some kind of the same scale, but then so that when you try to like penalize each and every one, it will be affected. Now the purpose to that one is that you know, for example, let's assume that you are having a scale. The one is using, for example, 10. Then there's another one which is using, for example, 1,000. For example, let's say you want to penalize them with let's say 40. I want to penalize them with 40. So you'll see that the one that has, for example, 50 will be penalized much compared to the one that has 1,000. So you want to find a way to scale everything so that, for example, if you're going to apply some penalty on everyone, like each and everyone will be affected very well. So that is the purpose of the standardization, or maybe the you know, there's something called regularization of the models, and of course we have the normalization and standardization. In this case, we'll be using the standard scaler for standardizing the dataset, still from the sklearn, from sklearn dot preprocessing module preprocessing. We are going to import standard scalar is a class, and then also we are going to require the algorithm for training the model with. So from sklearn, from the sklearn dot ensemble, and then from sklearn ensemble we are going to import. We can import the random forest regressor. Now the reason it is regressor, it is because the data, this is a continuous data. This is a you know, what do you call it? It is a quantitative one. It's like it's a continuous. For example, the price could vary, but then if it were categorical, let's say you have a fixed output, then we'll be using the classification. But then this is numbers, it's a continuous thing. So you use what? Regressor, so random forest regressor. And then of course you can as well have the gradient. So these are the ensemble method, gradient boosting regressor as well. Remember, they are also classifier regressor. I hope that's the name. And then we can as well have, there are some models, there are some features which are linearly related to the response. Like there's some kind of an increase, so this one is going to affect that one. So we can have a very simple linear model for that. So I can say from sklearn now we are having several of them, but then we shall synchronize all of them to make sure the model prediction is very perfect through the ensemble method, ensemble learning. So we can have the linear linear underscore model, we are going to import the linear regression model. It can help us, especially linear regression. Don't just say a linear regression. It can help us on matters dealing with the continuous data. We'll be able to just investigate everything. Then we shall try to incorporate all of these models, make sure that the score is very perfect. And then also we will require to test the models that we will have so we shall use now a file from the scikit-learn library, scikit-learn library. So from sklearn dot metrics, we are going to import some evaluation metrics here. We're going to import mean underscore squared, mean squared error. Of course, we shall convert it into the root mean squared error so that it can be on the same scale with the features. And then also we'll require the R squared score, score. Also, we can have the mean absolute error. Remember, on this matrix, the smaller it is, then the best the model is performing. Remember, it tries to these are like the errors. These are like the errors. Like these metrics, they measure the errors. So if the error is big, it means the model has performed poorly. If the error is small, it means the model has performed best. So the score will be checking if it is very small. And of course, we shall also require the Pico library. So I'm going to say import Pico. So this one, you don't need to install it. It comes with Python by default. Now let me try to run first of all. If I'll get an error, it will mean that there's something that I haven't imported well, or maybe there's a typo somewhere, or maybe there's a library which is missing. So like you can see, okay, I forgot this should be Cbon, C not R, there's no R there. Let's run and see if we're going to get also another error, so that we can be able to fix. Now this is the advantage of working with the notebook. Like you can be able to execute code cell by cell as you continue. So you can see now there's no error, it has completed to run. When it is running, it will show you the asterisk, but then once it has completed, it's going to show a number. Yeah, so basically this is very, very key. And then now the next step, we can try to load the data sets. Let me write here, for example, I can use a markdown so that it can be descriptive. Example, step 2. Step 2 here, we are going to load the data set. We're going to load the data set, and then maybe we can have something like that line that's going to like kind of okay, first of all, let me try to just make it so so let me just use Python code instead of the markdown. I don't want to complicate anything for someone who's a beginner. Let me just use the normal Python comments instead of the markdown. And then here I can say, for example, print like at least a line to show that we are trying to separate elements. So we can use something like this equal, but then we can multiply it so that it can be able to generate several lines, like a separator, something like a separator. So I'm going to multiply by, for example, the number of those equal sign that I want, for example, 60. Let me try to run first of all to see what I'm trying to talk about, this line. Yeah, so I want it to be there, and then maybe I can say print here, maybe I can say loading the data sets. Let me say load the data sets, or you can even use it in capital. Load the data sets. Now load the data sets, and then we can as well have that the same thing here. Just to, I want to be very organized so that someone, if they want to kind of copy what I'm doing, like it will be descriptive. So now the data frame, we are going to save it inside the variable df, and we are going to use now pandas, which we imported as an alias pd dot read csv is a csv file, so read underscore okay, read underscore csv, and then we'll need to specify our data set. Now remember, it is on the same directory here, so we can use the relative path here. I can say house underscore data dot csv, and then of course, once it has been loaded, we can try to print a statement, for example. Now to make it like not in a continuous place, maybe we can use first of all a formatted string, then I can use like this special character for a new line, and then I can say, for example, data set loaded successfully, so that you can be sure you can debug every step. You can provide the loggers for every step. Data set loaded successfully. I don't know if that's the spelling for successfully. Loaded successfully, and then we can try to see the total number of records there. How do you know that? You can be able to, we can still use a formatted string as well here. We can use the formatted string, and then maybe I can say the total records. Total records. Now, since it's a formatted string, now variables, you need to write them in curly brackets. So I'm going to use now the length of the number of records that are there. So I can use, just specify there, the df is going to count the number of records that are there. By default, it's going to target the access 0, which is for rows, if you do not specify the access. And then if you want, for example, for the columns, then we can use them. For example, total features. Total features. Now here it will be now dot columns. So for columns, you need to be explicit. So you say columns, so that you can return the total number of columns, the number. Remember, the len is going to return a scalar value on the number of elements to specify it. So let's first of all run and see. Yeah, so you can see the data set has been loaded successfully, and then the total records there, there are 10,000. Then the number of features, there are 15. So what we can do here maybe is to display some basic information for statistical summary, or some kind of just know more about the data sets. So maybe I can write here, though you can use another cell, but then let me just write here. I'll copy this one, or we can even use the, okay, but then let's use a different so this step 3, I want us to, no, still it is in the, no, let me not, I can even maintain it here, because this is still on the data loading and understanding it. So there's no need to have, like, I want to be so organized. So instead of this one, let me try to even just create still on the loading the data sets. We just want to know more about the data set. So maybe I can say this one is to maybe data set overview, overview, and dataset overview. And then on this one, basically I'm going to use first of all, let's have a title there, and then maybe I can say Maybe if you want to retrieve some few records, we can use, for example, first. Uh, let me say n, for example, first. Now this is a line break. Then I'm going to say, for example, first 5 rows. If you want to see the first 5 rows, then we can use the numpy. Now in a new line, I can use now the not numpy. Sorry guys, I said you can use the head from the data frame. Remember we have saved in the variable called df for the data frame. So on this data frame, I can use head, which is going to return the first 5 records, so that at least you can just see how it's going to look like. So for the first 5 records, and then if you want to see the dataset info, okay, should I run this one first? You've seen the first 5 records for individual. Remember indexing start from 0, 1, 2, 3, 4, 5, like a 0, 1, 2, 3, like that. So these are the features. We have the square feet, we have the bathrooms, we have the bedrooms, bathroom, the AGS, the garage spaces, the lot size square feet. We have the floors, the crime rate, the school rating, the distance to city in miles. It has pools. For example, it has the fireplace. It is renovated. Neighborhood, quality, and then now the price. Now the price is what we are trying to predict. So these are the features that we are going to use to determine the price. So we can try to see some info, some stats. So maybe we can say datasets. Let me say dataset info. Datasets info. Now for the dataset info, we can use the info method, which is going to give you some basic overview of the datasets. Like at this one, as you can see, it has given me the range index. On this dataset info, it has given me the range index, which means that we have 10,000 entries. So 0 to 9,999, and then these are the columns that we are having, and then they are not nulls at all. They are not nulls because we will require the proper cleaning if there's nulls. So we'll require how to handle the nulls, but then since there's no nulls here, it means that we can skip that part of the data cleaning. Although we are still proceeding, we'll be able to investigate other elements. Now if you want to see some basic statistical summary, and then especially because it is a continuous data, so maybe I can say statistical summary, statistical summary, or maybe information. Basically what we will what we are going to do what we are going to do here is to, okay, actually the method that we are going to use is the describe method. Describe, and then I want to be very organized. Maybe this first this part was on the loading the data sets, so that it doesn't mix up things. So this other one, maybe I can say, for example, to maybe 3 step 3 step, or maybe let me say 2.1, then this is 2.2, so that 2.2, maybe here I can just say 1, step 1, let me say step 1 imports dependencies for the project, and then step 2, this is it. And then so we want to run some describe so that you can be able to see it. So on the describe, you can see now it's giving us this basic statistical summary, like at the count the number of rows. For all of them, you can see they are 10,000, which means they are known as. Then it's giving us the mean. It's like at the average standard deviation, the mean, the quartile. There's in the quartile, there's a upper quartile, there's max, and then this was yeah, the mean is here already. Yeah, so for all of them, it's going to give you like the minimum value. The mean, the mean is like the average. It's going to give us also the minimum value on square feet. For everything, actually, it's going to give us those basic statistical summary. Remember, I'm trying to rush for the sake of the video, but then I'll just take your time, explore the data sets, and then understand it very, very well. Very, very well. So the other thing that I'm going to kind of check on here, maybe could be something to do with if there's a missing value. Although the info gave us the missing value, of which there are no nulls, but then there's a method, there's an explicit method you can use for that purpose. So maybe here I can just change it to the data quality, because you need to have a very high accurate data. So let me say data quality check, quality check, quality check. So let me say check check missing values. So this will be 2.3. I want to be very organized like that. And then on this one, basically I'm going to just use I'm going to use, first of all, to make this thing like at least have some spaces. Some spaces, we can use a line break here. Maybe I can try to concatenate here with a line break, so that after that describe there's a space, so I can concatenate with the line break. Yes, like that. And then here I'll be able to maybe just to handle now to check on the missing values. Let me say missing values per column. So here should be missing values per column. We want to see if there's any missing value, a value on any column. So basically, the method that we can use there is null. Now basically, this is null method is going to return true if there's a null on a particular column. If there is no null, it's going to return false. If there's a null, it's going to return true. But we want maybe to see we just want to see the number. If there are nulls, how many? First of all, let me run without. So you can see this one is giving us like a true if there's a null, and a false if there isn't. But then now we can use you can use the sum, so that we can be able to see the sum of the values. So I'm going to use now the sum method, so that it can give you the sum of the, if there's there are nulls. So here you can see there are no nulls at all. So we use now the is null, which returns true, true if there's a null, false if there's no null. But then now if you wanted like the values, then you can use now this sum, which is going to give you scalars for individual column with the number of values that are missing if there is a miss. If not, then it's not going to show. Then the other thing here that we can try to check on, it is maybe there are duplicates. The duplicates is something also that needs to be handled carefully, because it can cause like the model to be very biased, not dependable. So what I will do here, I can create a variable. I can create a variable for duplicated. Okay, let me say check for duplicate, check for duplicated, or a duplicate. Let me just say check for duplicates. So I can create a variable for that. Maybe I can say duplicates, and then I can use from the pandas. There's a method called duplicated, of which this one as well is going to return true and false if there's something that has been duplicated. But then we want to get the sum. We want to get the sum of if there's a duplicated entry. We'll be able to know it, how many of them have been duplicated. Maybe you can also have a print statement that's going to now show us that. So let me say duplicate duplicates rows, rows, and then this one we can use that variable we just created, but then a variable inside a formatted string must be within the curly brackets, and then we see if we have the duplicates. So now when you run here at the bottom, you can see there are no duplicate entries. So this data is high quality. That's why there are other steps we are going to miss, like handling the missing value, the duplicates, and all that. If there were missing value, there are two options. Either you remove those rows completely using the drop now for the entire data frame, or you can use the fill now. But then now on the fill now, you need to target specific columns. You can target specific columns and then try to fill it maybe with the mean, mode, no, not mode, yeah, perhaps, or maybe any other thing that you might want to fill it with, and then just to fill. And then for the duplicates, if you are to have the duplicate, then there's a method that you can use to drop as well those duplicates. But then for us, we are going to skip that part because we've seen the quality score here is perfect. You can see there's no missing values, in the columns, and then also there are no duplicated entries. There are no duplicate rows. So which means that we are good to go. And the next part we will need to do the exploratory data analysis just to know more about the data sets. Although the describe method gave us some brief overview, but then we'll need to be explicit for that. Remember, apart from just working on this project, it's kind of teaching. I'm trying to teach you guys, especially those who are new here, to know these stuff very well. So the next part will be doing the exploratory data analysis, but then a quick overview. What we've done here, we began by loading the data sets using pandas, so read CSV, and then now the data sets. And then for the basic info, we use the info method. For statistical summary, we use the describe, and also to check the nulls and the duplicate. These are the methods. This is very key so that you know what kind of the data sets you are dealing with, especially this info is very key because it's going to give you the number of records, because if it's big data, you need to be very, very careful on how you're going to handle them. Otherwise, if you want to process everything, it can slow down your system. Yeah, so guys, I want us to go to the next step on exploratory data analysis. And for this one as well, I'm going to just copy something here. This will be now step 3. We'll need to do the EDA. It's very, very important. You understand the data very well, if it's ready for the usage or not. So let me call it step 3. Then I'm going to say exploratory. This is exploratory. Just to explore to explore the data set. Exploratory data analysis. Data analysis is more for exploring the data and also understanding it more. Now on this one, basically I can just change it to exploratory data analysis analysis I think, yeah, analysis I think, yeah, that's it. So basically on this one, what we'll be checking on, it is now the distribution of, for example, the target variables, We want to just see the distribution of the target, or maybe the response, what we are trying to predict first. So we'll be checking, for example, those are statistical stuff. So let me write here a comment. Maybe I can say let me say distribution of variables variable sorry, let me write distribution of variables variable, the distribution of the target. Let me just say of the target variable, and of course this is price. The response variable should be price. Yeah. Now basically on this one, maybe we'll be trying to check on the now basically on this one we'll be trying to check on the just price statistics there. Say let me say price statistics. Price statistics price statistics, and then on this one basically we'll be checking things like the mean, median, and so forth. So for example, for the mean here we can have, I do not need a line break on this one. We can say for example mean mean price is like the average of the price there. So basically on this one, assume that the currency, actually because I know I have audience in different nationalities, let me use a pricing like in dollars. So here I can write now this dollar symbol, and then from the data frame here we'll be targeting the price column. You can as well use the dot or use this square bracket to target a feature. And in this case, the feature here, it is price. You want to use now the price like the response variable, price, and then we'll need to, first of all, we'll need to sort. Actually, we don't need to sort. Actually, for sorting the event, for example, we wanted to. Let's use let's start with mean. Mean, actually, you can just say there mean, and now this should be after this feature. So at the end of it, you say mean, mean, and then maybe we can change it to a 2 decimal point. Maybe you can say comma, but dot 2 decimal places, 2 floats like that. And then okay, now because in the inside I've used this single quote. In the outside, maybe I can use what the double, so that we will not have those issues of the syntax error. So this is to get the mean. First of all, let me try to run and see. Okay, not this one, actually should be this other one. Yes, so the mean price, this is the average of the price. Now let me try to duplicate this one, and then I'm going to do it for several of them. And then I'm going to have, for example, something like the median. Now remember, for the median, let me say median. First of all, I need to reload. Let me reload this one because the notebook is kind of misbehaving. I will need to reload this thing again. I will need to run this once you've reloaded. Actually, I'm doing this because my notebook is kind of misbehaving. And then here, now I will try to, for example, the median is like at the midpoint of the sorted arrays, or maybe lists, median price. So basically for this one, I just change here the method to median. I don't know why it is. Let me just say median, and then for the mean, we just say mean. Mean is like the minimum value, not the mean. Sorry. this should be median, this should be median, and then this should be mean, and then this should be now minimum value, mean value, mean. So for the mean, actually I'll just use the mean method, mean, and then for the max, I will use max, and then here just change it to max, max, and then maybe for the standard deviation, okay, don't know why this thing is really didn't. Let me say for the standard deviation, let me just say STD for standard deviation of the price. On this one, we shall just use the STD method, STD for standard deviation. Yeah, so as you can see, okay. Let me reload again. I don't know if this thing is really misbehaving this way. But then for you, if you'll be using the notebook, I think, or if you're using now the collab, I think it will not have these issues I'm experiencing. Only that when you use it like locally, it's much more faster than the one on the web. That's why I'm sticking here. So when I run this one, I think you can see now the mean is this one. We use the mean method. It has given us the average price. The median, it is this is the price for the median. I'm assuming that this is to buy the houses based on that data set. Now the mean, this is it. Then now the max house goes to about $1 million. And then the standard deviation, this is it, like the variance. Yeah, so the other thing we can also try to check on the correlation between the price and the other stuff, so that we can at least be sure what are the features which are contributing more, and what are the ones that have the weak correlation there, or maybe they are not having some kind of relationship at all. So let me say correlation analysis. So it's also very important on exploratory, because you will need to just use the features which are really contributing to the model prediction. So let me say correlation analysis. And then let me say correlation. Okay, what I will do, I can try to have this one as well. Correlation with price. Correlation with price. Correlation with price, and then here I can create a variable. Let me try to just make things simple. Here. I'm going to say create a variable for correlation. So correlation. Let me use small. Correlation. Correlations. I'm going to save it on the variable called correlation. So from this df, I'll say now .core, of which it will give us the correlation matrix, this one. But then we will need to target the correlations towards the price. Like we'll be checking like the features towards the price. So here I'll be targeting the price, which is like our response. So price, the price, and then now we need to sort those correlations in the smallest to the largest. So dot sort underscore values, sort values. Values we can will it? Yeah, let's begin with the one in the capital. No, not in the capital, actually the biggest, right? So it will be ascending. Ascending, I believe that's ascending. Okay, like ascending, we can give it false. so that it can begin in the descending order. So I hope this is the spelling for ascending, otherwise it will give us the error. So we want to know the correlation with the price, and then now so features correlation with price, I'm going to maybe create a variable for that, so that at least it can be something, we can have some kind of text for that. So let me say features correlation with price, and then we can try even to print. Let me say print correlation matrix. No, not matrix. Just this one, correlations, and then let's see. Yeah, so basically you can see it has given us the correlation, and then the correlation, now the price to itself of course should be 1, but then there's a high correlationship between there's high relationship between the square feet and the price. You can see 0.88. The bedrooms also contribute to the price. For example, 1 bedroom could be slightly cheaper compared to a 4-bedroom. Bathrooms as well. Bathroom, these are slightly, actually they are slightly lower. As you go down, they are getting lower. So the lot size, square feet, sometimes it doesn't matter. That's why you see there's no such remember, between like a 0 is like the strongest, and then now 1 is like a, okay, 0 is like the least. It's not like there's no relationship at all, or maybe there's very low, and then now 1 is like there's high correlation. So if you see something approaching or maybe deflecting towards the side of one, it means there's high correlation. And then 1 goes towards the zeros, it is poor correlation. So you can see these are the correlations, also the number of loss. But then, as you can see, even some of them, it has some inverse. Like for example, the crime rate. It is affecting the price, but then on the negative side, that's why you can see it is in the negative. The distance to the city as well is affecting it negatively. The AGS is also affecting the price prediction negatively. So at least we know what are the key things to determine the price. Mostly it is the square feet, of the house, and then now the bed. These are the top features that are going to help us know what we what features are really needed there. So now the other thing that we can be able to, or let's just create a variable to identify. Let me write here a comment. Maybe I can say, for example, let's try to identify. Remember, I'm trying to do several things here so that a beginner can also be learning something. Identify a highly correlated features. Features are like those columns that we are using to predict. So maybe I can say a high underscore correlation. So still I'll be using that correlation that has been saved on this variable. I'll be using this one, but then I'm going to use the absolute ABS, and then on these correlations which are more than, let's say, more than 0.5, 0.5, to know which ones are. Although we can just tell based on what has been produced earlier, we can be able to know. Now here we want to filter out there, because you can see you can see the price gave us once, like you're trying to compare itself by itself, so it is not really needed. So we can use the drop. We can drop it so that it is not part of the list, because that's what we are predicting. We're trying to predict. So we can drop it using the drop method. So let me drop the price. I'll drop the price so that you can just filter out those that are having high correlations there, and then let me say highly correlated highly highly correlated features features which correlation or which correlation is more than 0.5. Remember, it's just a string. So here we'll be able to print this high correlated. So it's just a filter. Remember, these things are not necessarily, but then I'm doing it for someone to learn. Yes, so you can see we only have the square feet, and of course you can just be able to directly see it here, but then also you can as well use the method to help you on that. Yes, so I think now on the exploration it is quite clear. So we know that the one that is going to really affect the price, mostly it is the square feet, but those other things you can see they have some impact on it. Those are the parameters, they have some impact as well, but then on the lower side, on the small portion, but then it is still important to have that because we see they have some impact on the output. So now after this exploration, then the next step you go to the data pre-processing. We need to pre-process our data set so that it can be ready for the machine learning. So let me say data. So this will be step 4. Step 4, which is this one will say data pre-processing. Data pre-processing. So we want to make sure that the data is now ready for the machine learning. Actually, we've done all the exploration. Maybe you could have done the cleaning and everything is ready, but then now you want to make it like ready for the machine learning training to train the model. So you need to pre-process it, like renaming the columns and stuff. So maybe I can say something like let me see. You know, I want to say, for example, separate. I want us to separate. Separate features and the target. I want to separate the features and the target. So first of all, mostly when you are trying to pass like this information to train the models, on those algorithms we just need the x-axis and then the y, which is now the response variable. Now remember, x the features could be more than one, so but then still should be within a variable x. So maybe we can create now this capital X for the feature. Let me use capital X. Now the feature that we are going to use to predict the price is going to be all these features there, every feature there, the square feet, all these features, apart from the price. Remember, some of them, they have some negative impact on the price, and also it is important because they are determinants, so that at least you can be sure of the model accuracy. Remember, if you just rely on one feature only, like for example the square feet, it might not give you, it can give you the best result, best score, but then it's not something reliable because there are several other factors that are contributing. So we want to use everything there for the features apart from the price, because that's what we need to predict. So it's going to be the data frame. It is stored in the variable df, but then I want us to drop the price and of course should be in the column. Like actually this data is in rows and column. There's a column, then there's rows. So you need to be explicit to say, now for rows you don't need to do that, but then now for the columns you need to specify the axis so that is going to be aware that we're trying to target now the columns. So maybe I can say access 1 is basically 0 for rows, 1 for columns. So this one, I'm trying to remove the price from this data frame on the column side. And then now y you can use it in small because that's like the response. Now the y from this entire data frame, actually there's no need to drop anything, which can just target only the price, the price, and then maybe we can try to print out something. Maybe we can try to print out some few things here. Maybe we say features. Let's say, for example, features. They are in the variable. Features, they are in variable capital X. Want to know the shape of it. Shape. So if you're using now the formatted string, then we write it in curly brackets, and then x, then dot shape attribute is not a method, and then for the target, let me say target is what we are trying to look at. So let me say target, or maybe what we are trying to predict. Target. Target. So the target should be y. So it will be now here y. Y dot shape. So let's try to see the shape. Yeah. So basically, yeah, the shape, actually this shape, it is returning an array. Like if you see two elements in this tuple, it means it's a two-dimensional array where the first axis represents the number of rows, which you have 10,000, and then the columns are 14. So this is for the features. But then on the response, since it's already 1, remember features, it is saying here 14 because it's not one element, so like there are several features. But then now the target, because it's already for the price, you only require how many? First of all, when you see here one element, it means that's just an array, just a single column series where it has 1,000 records for the price. So this is very key. The other thing, we can try to split our data sets into testing, and then partly into testing, and then for training as well. I don't know if I should do it on the okay, let me just maintain it on the data. Okay, first of all, it should be data preprocessing, data preprocessing. So here as well, we can have, for example, the train test split here. Maybe I can say now 4 points. Let me say, for example, 4.1, 4.1. Now I think I should be data preprocessing. I think I should specify the steps, right? Let me just specify steps as well on this thing, so that someone will just know the flow. Step 1, and then 1. This is step 2. Step 2. Wait. Yeah, step 2, and then step 2. This is still step 2. Let me run. So there's a step 1. Step 1 was loaded earlier. Maybe also for step 1 we can as well have something like that as well on it. Step 1. I just want us to be organized, guys. That's the reason. That's the major reason I'm doing this stuff. So step 1, data import. Okay, let me just say import dependencies. Import the dependencies. Once you have imported the dependencies, then you can load the data sets and some other things there. Then now this should be now step 3, which is now exploration, exploratory data analysis. And then now once the exploration is done, then the second step, the other step here, it is data preprocessing. So step um, 4. This step, wait, step 4. This will be now data preprocessing. So still under the data preprocessing, I want us to split our data sets into training and testing. So let me say split. I'm at 4.1. Then I hear 4.2. Split. Let me say let me just say split. Yeah. Split data into training and testing. Training and testing sets. Now let me tell you why this is important. Let's say you're trying to you want to teach, for example, a student, a baby, 1 plus 1. For example, you want to teach the baby, for example, some basic mathematics. So you're telling the baby like a 1 plus 1 is equals to 2. So if you'll ask the baby again 1 plus 1, there will be high chance of the baby telling you it is 2, because you've just used you're trying to ask the question that you have already previously provided the answer, like 1 plus 1, 2, and then now you're asking the baby 1 plus 1 is, then there will be high chance of the baby getting it right, because you're trying to just ask information that you have already provided. But then, for example, if you are training the baby like 1 plus 1 is 2, and then you're asking the baby 2 plus 2 is what? So this is something new. So if they'll give you correct answer, then that's what you mostly rely on. So that's why on this model, we're trying to split our data set so that most of the portion will just go on the training, and then now the second part of the file of the data set, which is unused at all on the training, it's something new. You can use it now for testing the model. So you'll be relying on something new, the second portion of the data set that you will have split, so that you can really rely on the model. So we are going to create the variables that we'll be using on the train test split to split our data set. So first of all, we'll require the features on the training set. So we can create a variable for xtrain, and then also we'll require also the features for the test, and then also we'll require the training no, like the y, the response on the y. So we'll require the y train. So this is like the responses. So for example, you're trying to tell, for example, the features when you're trying to train the baby mathematics will be like 1 plus 1, and then now the response is 2. So the response in this case is like at this part of the y. Then now the features, like at that one, you're trying to say 1 plus 1. It's like the y, 1 plus 1. Then this is like the answer you're trying to provide. Also on the testing, so we'll be having the test. So we'll be giving out the testing, for example, 2 plus 2. And then, of course, you will need also to provide also the solution. No, not to give the student the solution, but you at least have the marking scheme somewhere where you'll be comparing. For example, if you give them the test and then they give you the score, you'll be comparing with what you already know, the marking scheme. So just to analyze, for example, to assess the performance. So I will use again the y underscore test. So this is like at the marking scheme, like at the preserved accurate score, so that will be comparing with what has been predicted with what was required. So these are the variables that we are going to pass on the, we are going to like store the train, this algorithm that we imported there, the top train, test, train test underscore split is a method, is a function, is split. And then this one you need to pass in your feature variables. So the feature variable in this case it is x, and then the response variable here it is y, and then now you need to specify the test size. Test size is like which portion of this data set you want to separate for the testing, so that the remaining part when you will be training the model with is going to spare those portion such that you can use it for testing. Remember, it should be something new so that you can rely on that score. So for example, if you give it, for example, a 20% on the test size, so that should be 0.2 for 20%, which means a lot of data is going to go to training. Now, the same case, for example, when you are in high school, you can learn more. There are many textbooks, there are more notes, but then in that test, in the final test, maybe you ask some, even 50 questions, like something that you can just fill within some 3 hours, yet you've learned something from let's say first year, or maybe let's say if it's high school from Form 1 to Form 4, but then now the question that you are asked, they are something that you just fill or maybe answer in 3 hours max. So the test says you want to make sure that it is like a small percent, so that most of the data will go for the training, because you need to have more information so that when you ask, like you can be able to produce answers. So this is the test size. When you give it 0.2, it's like 20% is going to go for the testing. And then now remember, it's going to select those records randomly, like on there, to make sure that it is balanced, or maybe it has selected everywhere. It usually select it randomly. The 90% on the training is going to select it randomly, and then also on the testing size is going to select those records randomly. So once it has selected those random records, you'll need to maintain those randomly selected. So for future testing and other stuff at the bottom that we're going to do, so we need to retain that random selected records. So we can use a method called random underscore state, of which it takes an arbitrary value, could be any number here, for example 42, 43, any number there, of which is just an arbitrary data. It's just used to retain the randomly selected records. So this is on the train test split, and then maybe we can try to kind of print something on the same, so that we can be able to see what portions is for testing, and then what portions will go for the testing. So here I'll say, for example, the let me say train set size. Train set size on this one, I'm going to, the train set size, basically here I'll be using now the x. This is x train is the one that we'll be using for training. So here, to get now the number of records, we can use the len function, which is going to return a scalar value on the number of records that have been preserved or maybe separated for training. And then maybe you can also get some kind of a sample percentage. Let's say a sample samples. If you want to get a percentage of this stuff, you can still use the same len function. Then we'll pass here the x train. Now it will be now over the total, of which is now like at the length of the x, which is unmodified length of x, which hasn't been split. Remember here, this x is like at the original one. So when you say here x, is like you're trying to say the training portion over the total. Now it will be now times times here times 100 to get a percentage, but then that percent you can turn it into some decimal place. For example, 1 decimal place. So it will be, oh, first of all, there's something that really something that I really there's something that all right, it's fine. Yeah, so this is for the train, and then now for the testing. For the testing, I think I can just duplicate this one. For the test, I'll just change it to what do we call it? It is okay, it is X, but then I'll test. In fact, let me just copy here. X test, and as well, we can as well use the same portion. So we just want to know, to confirm. Remember, these are necessary, but then now for teaching purposes, remember this is still part of learning. It's not just completing the project. So I'm getting the error. I'm getting the error there is because it is because, let me see. The length of the x. Oh, okay. What we forgot here is like to wrap this one. It should be in this thing, in this because we are targeting out this x. So this way now we are going to do it with the length of the x times 100. So it means that there should be no extra brackets. Like I forgot to close it properly. So here I'll just change it to again test. Now remember, debugging is a skill as well, and also getting bugs is also constant. It's also something that you must always expect. So it has given you the features, the number of records, and then now the Y also, and then now on the training set you can see it is 8,000. That's why you saw earlier it was 8K, and then the portion is 80%. The test size is 2,000, which is 20%. Okay, I forgot to add in. Let me try to add in something like a percentage, so that it looks really nice. So that it really look nice. So maybe here, no, I should add in the percentage here. I forgot. Not on the wait. There's something that okay. Yeah, percentage. Yeah, let me see. Yeah, 20%. This is fine. This is very fine. So this is just on the data preprocessing, but then also we say that these data are of different scales. Like you can see, we have ones that are in ones, we have the ones that are in tens, we have the ones that are in hundreds, thousands, and so forth. So we need to regularize. We need to like kind of put them on the same scale. And then for that one, we can use the algorithm for the standard scaler. So again, here maybe I can I can just say, now this one is like a new one. This is not like 4.1, 4.2. Then maybe this one I can say, for example, 4. 4. This should be 4.3, right? Wait, let me have it 4.3. 4.3, but 4.3, but then here I'm not going to have it like let me just say feature scaling. Let me say feature scaling, but not like a step. So let me say feature scaling. Let me write in capital. Feature scaling, and then let me just say here feature scaling. Now remember, this stuff I'm doing this one intentionally to guide someone who is new to know the steps that I'm really taking, so that it can be like a roadmap, a pipeline, or maybe a template whenever they'll be working on their own project. So feature scaling, and then now for this one, we'll need to standardize this record so that we can have them on the on a standardized scale. So I'm going to create a variable I can call it scalar perhaps, and then I'm going to use the standard scalar. That's what we imported there at the top, so that we can use it for standardizing or maybe for regularizing our model. So there is a class, and then we need to create an instance of it or instantiating, and then now we can have, for example, the x underscore train underscore scaled, so that we'll be using we'll be training the model with the scaled data sets, so that they will be receiving the same penalty. Like the penalty will be affecting both. It's like you're trying to use a percentage. For example, if you want to detect, for example, you want to apply some tax on some people, like when you use now the percentage proportion is going to be very effective. It's like someone, for example, you're trying to impose 10% tax, while someone is getting 100 shillings, will be able to give out 10 bob, and then the one who is earning, for example, 1,000, they will give 100. So this is like this is very fair. So that's what scalar does. Like it's going to like standardize such that when you try to penalize one column, it's going to affect all. Like when you try to penalize all of them, it's going to affect everything equally. Remember every feature I've placed it in a variable x that's going to stand for all the features and their values. So we'll need to make them on the same scale, so that if you are trying to apply something, it's going to affect everyone equally. So this is the work of the scalar standardizer. So let me, from this scalar, standard scalar, I'm going to use the fit transform, that is to transform those are features. This should be transform. Now we'll be transforming what? We'll be transforming the X train. X train, remember, is going to store all those features. Then 80% of the features we're going to transform them. Also, we'll need to transform also for the test, so that we shall as well test the model with the same value scaled data. So here's going to be X test as well. The X test, and then maybe we can try to kind of print something just to see what you know, just to see what has happened. So maybe here I can say still feature scaling, but then just want to see the printing the or maybe let me just say this instead of the comment. Let me just say features scaled using standard scalar algorithm, and then so basically this is what is going to apply for that purpose, like on those and that this is what is going to happen, like on that standardization, what is going to like how it's going to scale it. Let me give you like some kind of a formula that is going to use to standardize. So basically the formula, let me write here the formula that it is using for that. So remember, we are targeting what? The feature scaled one. So basically it's going to use the kind of a mean. It's going to use like the x from the mean. Okay, let me put it this way before I write. Let me just try to demonstrate like what the standardization tries to do. First of all, it's going to analyze, it's going to like based on the scores you'll be having. Let me try to demonstrate on a whiteboard. Or maybe I can just even use here. I'm going to delete in a moment. So for example, let's assume that these are the responses you're having. For example, someone has gotten a particular score, that something, whatever, some values, and there, like you have those kind of data. So let's say these are the scores the student the student have. Let me use something that maybe it is 90, and then maybe, for example, uh, 40. So what this is going to do is, first of all, going to get the average or the mean for all the values that are there. So assuming that maybe the mean is, let's say, around 60%. 60 is like the mean for these scores. So if you want now to standardize them, then we'll be getting out the differences from the distance of the x of the feature, for example, of a particular value. For example, a student has scored maybe 72, so you'll be taking that 72, you subtract from now 72, then we'll be subtracting the mean. Now the value you get there, it will be somehow small. Remember, in regression we want to achieve like a smallest value as possible. So like at the distance from the mean is what we call, like at the distance of that value to the mean is what is now the variation, or maybe for example, let me say if the distance is big, then it means that if the distance is big, it means that um, it will mean that okay, like basically going to calculate those distances like that way. Actually, the purpose is just to make them have the small scale. So, for example, those that are very those that have very small, which means they are performing poorly, and then those that are have, for example, high, including the, for example, let's say someone has received 98%, so we'll be subtracting now that 98. You are subtracting mean from that 98. Now the value that you will be getting, it will mean that that is now the value that has been standardized, that you will be using there. So this is what the standardizer scaler is trying to do. So it is the feature is going to use like the specific feature, and then the mean. The mean is like the average of all the features that are there. So we'll be getting out the distance from the distance of the mean from the actual feature, and then over the standard deviation, like the variation. Let me say standard deviation. So this is what is happening on this standard scaler. Remember, the objective is to make it have smallest value, because we actually need the smallest value if you want to the model to perform well. Remember, the smaller the error, the better the model is performing. So when you're having now smaller value, remember the metric that we'll be using includes, for example, the mean squared error. So if you have a bigger value, then you want to square it, it will be even much bigger, like 1 times 1 is 2, but then when you reach to 100, then it's going to go to a higher value. So you want to make sure that you're trying to reduce it in the smallest value possible, but then it should affect everyone. That's why we're using this approach. The model is using that approach, so that you're trying to make sure that you are using like less numbers but then it's affecting everything, so that when you try to use it, like the result will be overall very small. So that's what the standardizer is trying to do. So what I'm going to do here is to maybe use a formatted string first, and then maybe try to write something there. So let me say sample before scaling, sample before scaling. Then I can use a new line. Then we can say extend.ilog. No, it was extend this one. Now to target the first for example, if you wanted to target like the values on this extend here .ilog, and then now targeting the values there, so I need to use now the first index now dot values of which is going to come as an numpy array values. This one is going to give us like the sample before scaling, how it will look like, and then now we shall have the one after the standard scaler, which is now this one. This is on the train still. So in a new line, it's going to actually this one we're going to just we don't need require actually the values. The first need the values. So let's just try to see how this standard scaler is trying to do. So as you can okay, so basically because we actually need to just get the first one. This one has already been standardized, so actually we don't need to have this ilog. We just need to access the first one. We just need to have the first one. So yes, I don't know how it is misbehaving. Again, I will need to save it and then let me restart. Once I've restarted, I will need again to run this thing. And I'm so sorry, I'm repeating this most of the time. I'm repeating this most of the time just because the notebook is misbehaving sometimes. Yeah, so basically, you can notice on this one, the sample before scaling, you can see how it was using the at the values there. But then now on the once it is standardized, you can see they are all in almost the same scale. Like at they are in between. Like at the scale, you can see they're almost in the same range. They are using the same range. Yeah. So this is the purpose of these standard scale, just to make them on the same scale. So the purpose, remember, many machine learning algorithm is going to perform better when the features are on the similar scale. And that's the reason we are using that scaler, just to make sure that each features they are in the same scale, so that the model will perform based on all of them. So that's on the data processing. The next part we are going to handle the training multiple models. We're going to train multiple models here, maybe step 5. Now I want to train the machine learning. Now that we have prepared everything is ready, so let me say model training, and then step 5, let me say model training, so one not train the model, and that this one we're going to use several models. Remember, we imported several models here. We have the random forest, gradient, boosting, regressor. We also have the linear regression. So we want to train all of them. So these models, maybe they are scores, or maybe they are solutions, or maybe they are scores. Maybe I can give them inside a variable called model. Sorry, let me just maintain this one. I'm going to use a model as a variable or a dictionaries that is going to store all the model predictions. Remember, we are going to incorporate the ensemble learning, so that all these models will be incorporated to make sure that the score is much better. So here I'll give it an empty one because we haven't trained yet. So we're going to start with the linear model. So let me say model 1. This one is going to be a linear regression. Here, what am I writing here? Let's use the linear regression. Linear regression, and then basically on this one, maybe I can let me try to print first of all. Remember, we have 3 models, so maybe I can say import 1/3, maybe something like that. 1/3, and then this is going to be training a linear regression, training linear regression, and then maybe I can use a variable like LR for linear regression model. And then on this one, we are going to just call that instantiate the class for the linear regression. This is the simplest one if the data is following some kind of a linear pattern. So this one, and then we shall also need to train it. So this is like trying to just instantiate, but then we need to fit it. To fit is like you're trying to train the model. So we say now linear model, this one model, this class or the object, the instance, you're trying to fit it with the training set. So the train set, you want to make sure that you're using the scaled version. Make sure that you're using the scaled version on the train. And then of course the response, we don't need to change anything. We didn't scale the train because that's like the response. You don't need to scale it. So this is what you really need. So here I just say y train is like what you're trying to, the results. Now the results, the original results, this one. So this is what we are trying to fit the model with. Like you're going to give it the features and then their response, so that sorry, where I should be on the fit. Sorry guys, I should be on the fit. So like we're trying to fit the model, we're trying to give it like their features and then their responses, so that in future, based on how you train it, it should be able now to predict now the future stuff. So from these models, now it was initially empty. We can try to give it a new value. So I'm going to say from these models, once it has trained that one, then we are going to incorporate what the linear model here, linear regression. Linear regression is like the key, and then now the value will be from this trained model. We're going to store them on that models, and then we can be able to maybe try to print out. We can try to print out, for example, the linear regression trained. You can see how training the model is very easy. Like a lot of work is happening there on the data preprocessing, data analysis, like all the data engineering is where there's a lot of work. But then on the training the model is just easy. You can just imagine these few lines of code, it has already trained the model like a machine learning model. So the next portion here, we want to also incorporate the random forest, which is a homogeneous ensemble method. So let me say random. So this should be 1, this should be a 2, and then this should be now random forest. So this is still an ensemble learning, which is trying to incorporate several decision trees to regressor. Decision tree to make sure that the score is much better. So this is going to be now 2/3, and then this one is this is to train the random forest, training random forest model, random forest. And then on this one, actually the class that we are going to use here, it is the random forest. But then now on this random forest, like the trees that you're trying to use on these homogeneous. So you need to specify, for example, the number of trees that you're going to use on this forest. So you need to provide them under the parameter called n_estimators. Like you need to give it the number of trees estimators. you need to I think meters. Estimators, if it give us the error, we'll know how to n estimators. You can give it, so for example, this data is around it's around 8,000. This is what we are going to use on the training. So if you have something like 100, 100 is fine, so that each one is going to use 80. It's going to use 800, 800, yeah, 800. And then also we can have the max depth, like how much should the tree grow. Now remember how many features. So these features, when you say, for example, max depth, like how the tree should grow, because we have several features. If you give it something like 20, it's not bad. Remember also, if it will be too much, it will incorporate the noise. And then if it's going to be very few, then it's going to be like you not rely on it because it hasn't incorporated many things. So there will be an aspect of the noise if you give it more, and then if you give it less also, it's not going to be that accurate. And then of course you need also to specify the random forest on those random stuff that it has already selected. You need to use the random state as well. Random state, you give it an arbitrary value, for example 42, so that on those estimators, on those random selected, it is consistent. And then also you can have also the n underscore jobs. And remember, you can always get the when you click on shift tab, you can always get some brief description, like for example what the n estimator, that is the number of trees in the forest. There's a criterion, it has given you also these details, the max depth, the maximum depth of the tree. If none, then nodes is going to expand until all leaves are pure, until all the leaves are contain less than minimum sample split. And then now the mean sample split, like a, yeah, so basically it's going to give you like a more details on these things. uh, N jobs, as I've said, is the number of jobs to run in the parallel. And then the random set, this is controls both the randomness of the bootstrapping of the samples used when building the trees. So like it's going to make sure that it's very consistent. So you can always get more when you click on shift then tab on Windows, shift tabs, then you are going to see more detailed docstring of the same. So on this one, that's what we are going to provide. And then here we are going to use random forest. Let me say RF. RF. Sorry. Yeah, the model, actually the model here should be the RF. And then so that RF, I'm going to fit it. The method is still the same, fit. Still the extrained scale. We want to make sure that we're using the scaled, and then now the response. And then here, maybe I can say random forest, random forest, random forest. So this is to the random forest. This like the second key value pair. The value will be using this random forest, and then maybe you can say random forest trained, or let me just copy this one. We can say random forest trained. So this is the second one. Is going to also store them in the models. So now we have two. We'll have two models, and then the last one here we're going to use the gradient boosting regressor. Gradient boosting regressor. This is the third one. And as well, this one we are going to use we are going to use this one as well. We are going to use this one. So imagine when you reach here, you have trained 3 models, you know, with just some few lines of code. So most part is on the data preparation, but once you've done that, then this other thing is just easier. So here I'm going to say gradient boosting. Maybe I can change here to gradient boosting. And then this one also, it can take the n estimators. Still let's maintain that to 100 rate. Maybe you can just give it even 0.1 for 10%, and then max underscore depth, max depth as well. We can give it maybe to 5 or something, and then also we'll need to retain the random state as well, so that to retain also those are randomly selected portions, and then here we're going to say, for example, gradient boosting, and then here we'll be using this GB model. And remember, I say that you can always get some brief summary when you click on the shift. You place first of all the cursor there on the algorithm, then you click on shift tabs, and then you can see more details, add some doctrine. So gradient boosting for regression, this estimator builds an additive model in a forward stage-wise fashion. It allows for optimization of arbitrary differentiable loss function. In each stage, a regression tree is fit on a negative gradient of the given loss function. So it will do that until it has completed everything, so that the final output is more reliable. So on the gradient boosting, so these are the three algorithms that I'm using on this model. So after that, we are actually done. Maybe you can try to print something like all model. We can say, for example, a user formatted string here. Then I can say, for example, all models are trained successfully. So if it will execute this last statement, it means that the training process was very successfully. So we can go ahead and try to run. But then now, before we run, a summary again. We're trying to incorporate several models here. And we began with the linear regression, of which this is just a very simple fast, and it assumes that the model, or maybe the features, have some linear relationship between those features and the price. And then now the random forest, this is in the ensemble of decision tree, multiple decision trees. So it is used to handle the nonlinear relationship well, and also it is very powerful or robust on matters of outliers. It handles them very well on the random forest. So this is if the data is not linearly distributed. And then now for the gradient boosting, as I said, this is like a build trees sequentially, each correcting the previous error. You know, and most of the time it's very accurate. Like, for example, if it trains a particular tree, it is still incorporating or using the decision tree. And then, for example, if it train it successfully, then maybe it has an issue, then it goes to the next one, and then it will be fixing the previous parameters. Yes, and then yeah, so basically these are the models that we have incorporated there. So when you it is training, so you can see it has finished training the linear regression. This random forest now is trying to train the sorry, the message here I forgot to change should be gradient boosting. Gradient boosting. Let me run again. So linear regression is much easier. Random forest, then gradient boosting. I again forgotten. Should be 3. Now there's a problem with the copy pasting. So 5 model training. It has completed one, second one, then the third one, and the all models trained successfully. Wow, congratulations, you've managed to train the models. This part so that I can just edit. So this is for the model evaluation. So this should be step 6. This is for the model evaluation. Model evaluation. And then let me just say a model evaluation. Model evaluation. So basically here, what we are going to do, first of all, we can save the results maybe in a dictionary, results for individual results. We can save them also in the dictionary. And then now since the model here, the model here, it is a dictionary which stores data in a key value pair, and I still an array like it stores a collection. So we'll need to iterate over them. It is an iterable object, a dictionary. So we are going to check on the like actually we'll be having two variables there. First of all, we need to get the name of the model, and then now I will be able to target the we should be able to target the name of the model, and then now it's now model prediction result. So we shall have the name and then a model because this dictionary stores that in a key value pair, so it will be now in uh, in models. Now these models, remember, it is a dictionary. So if you wanted to get these two elements, the key and the value, then we will need to use the items method. If you want to get values only, we'll use the values method. If you wanted to get keys only, we'll use the keys method. But then since we want to get both the name and the values of the model, then from this model dictionary, we're using the items method so that you can iterate over everything there. So maybe I can write as well something like to show you are trying to evaluate. You are trying to evaluate. For example, let me say evaluating, evaluating. Then I can use a formatted string. Formatted string. Then here I can say, for example, it is evaluating a particular model name here. Name. So once it does, we need to get the prediction. First of all, the prediction we need to remember. We have already trained the model, so we need at least know the prediction, and remember they are stored in the variable called model. Here, this model. So basically, what we are going to do. Let me just spell it. For example, y underscore train underscore trade. First of all, this one we're going to expect a high score because this is the training set. This is the training set. It's like you're trying to tell the baby 1 plus 1. You tell them it is 2, then you're again trying to ask 1 plus 1, what is it? So the accuracy will be high because you're trying to ask something that you have trained the baby with. So on the prediction also, let me write here. Here we'll be expecting prediction on the on the train prediction here. Of course, the results must be higher. We shall see that from this model. From the model, this one, we're trying to predict the X train as well scaled. X train scale it's at the top there. X no, not this one. X train scaled. X train scaled. X train scaled. Like I will just give it the features, and I know on the training the score will be high because you're trying to just use what you have fed the model with. But then now the accurate one, the one that will be relying on is like you've trained the baby 1 plus 1 is 2, and then you are trying to ask, for example, 2 plus 1, what is it? So that's something new. So that's like on this test, the one that you will have separated, you had splitted for the test, which it was 20%. So on this 20%, we are going to use now this where is it, X test scale as well. We want to know the prediction there. Once we have the prediction, then we shall be able to evaluate the metrics for individual one. We shall be able to evaluate the metrics. So let me say, for example, sorry, what is that? So let me say something like training metrics, so that I can be able to see the prediction. Now the first one is like let's use the train underscore r squared. So basically r squared is like it tries to give you like the variance between the for example, from what is supposed from the original, or maybe what the model is supposed to give you, and then now what the model has predicted. Now it is in between 0 and 1, the scores, where 0 means like it is poor, and then for example, if the variance is like that distance is big, then it means that the model has performed well. So we'll be using now this r squared score, r squared score, of which I've already explained what it does. It's going to give you some kind of a variance, the distance between the mean on the result, So the better, if it leans towards 1, then it means more accurate. If it leans towards 0, it is poor. Remember, this is only for the r squared, but then for other metrics like the mean absolute, mean squared error, and RSS, all of those stuff, and also root mean squared error, we know that the higher it is, the poorer the model has performed. But then on the r squared, because this is like trying to check on the variance, how far is it from the accurate result, from the original result. So if it gives you the best score, or maybe towards something towards the 1, then it means it is performing well. If it is towards 0, it is performing poorly. So here we will need to check on the first of all, on the training set, we are going to use now y underscore train, the y underscore train, and then you will be using now the y train, this prediction that the model has performed. So it's like trying to compare between the original result and what the model has performed. So we want to know the variance, the distances between the original and what the model has performed. So if they will be high, then it means that the model has performed well. If it's low, it means the model has performed poorly. So this is for the training set. Of course, we shall expect high score, and then here we can also have the training set root mean squared error, of which we shall just be square rooting the mean squared error. We shall just be square rooting that one, and it will still be from the it will be still from the now the square root. We can utilize the numpy. We remember we had already imported numpy. So numpy, it has a method called square root, which is sqrt, and then you can pass in the mean, the function we imported there at the top for the mean squared error, not really mean squared underscore error. And for this one, you will need to provide the Y train as well, the same parameters there, and remember they are storing the values in an array format. So the prediction is like in an array. So it is going to work with it because NumPy is very powerful to work with the arrays. So we're going to do that, and then now we can also have the mean absolute error. So on the training, mean absolute error. So this one assumes that there are no negatives. So it's going to square everything. It's going to not even squaring actually. It's just going to like assume that there are no nulls there. There are no negatives, and then it's going to do it, get an average of the same mean absolute error. So like it's going to, let's say, mean is like at the average of the absolute values, assuming there are no negatives, absolute error, and then mean absolute error again, we're passing the same parameters. Yes, so this is on the training, and then training metrics, and then evaluation metrics. Then we can also have for the testing, on the sample size for the testing. So I can say testing, and then for the testing, we'll be using now this one. We'll be using now this this one, and then here it will be wait. Here it should be train. Sorry, I don't know why I use this one. This should be on the training. I forgot. Sorry. This should be on the train. This should be on the train, and then this other one, this for the test. For the okay, test is fine. So here I'll just change it to test, Y test, of which is like something new, the new portion that was secluded. And then here I'll be using now the test, 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 like that. Yeah, test like that, and then now so basically the results we can still store them. So result, which was initially an empty dictionary, so we can now try to update it. Results, we can give it the name. It will be like the keys name. Name will be the keys. Remember, it is still happening under the iteration, which means that those names are going to be stored under the name. And then now the values, we can use the dictionaries for individual. So where the training, for example, this is a train R squared is an initial train R squared. We'll be using that variable, and then the test R squared, the test R squared, like at the key, and then now the value sorry, the value I'll be using now this test R squared, and then now for the root mean squared error. So for the train train root mean squared error, sorry, train root mean squared error, I'm going to use that one, and then on the test root mean squared error, test root mean squared error. Remember this for individual model train. So this one it will be using now the test root mean squared error, and then lastly the train mean absolute error is the key, then the value it will be using these results. And then now lastly we have the test as well of the same test, mean absolute error. We shall be using that variable there to store the mean absolute error for the test instead. So basically on the results, it's going to use a particular model. For example, if it is linear regression, and then it's going to give you the scores for the training set, and then now the testing set, because we had split our data set into training set and then testing set. And then we can even be able to print out the results so that you can be able to see something you can be able to visualize, or print out something you can be able to see. So let me say print. Let me say, for example, you can use a formatted string, by the way. Formatted string. Then let me say training performance. Training performance. Then we shall begin with the R squared. So R, let me call it R squared. Remember, this 2 is only that I'm not able to write squared. That's why I'm writing 2, but then it should be squared. R squared score, squared score. R squared score, maybe let me just say R2 to represent our squared score. On this one, actually I'll be using the I'll be using now these are train R squared here, but it needs to be in kind of decimal places. For example, because you know, let's use maybe some 4 decimal places so that you can be able to capture several parameters there, so that it doesn't round down. Maybe if it is 0.8 and then it's going to round down to 1, we don't want to do that. So let's have it 4 to 4 significant place, so that we can be able to so 4 decimal, sorry. And then I'll show this for the for R squared. Then we also have for the root mean squared error. Root mean squared error. So on this one, we are going to use for the train. Actually, the train is going to be this one as well. To this one, we can be able to use 2. 2 is not bad on the same. And then mean absolute error, still mean absolute error. So for this one as well, we are going to retain 2 decimal places. So this is on the training performance. Now for the testing. So for the testing, actually for the testing, I'll just be using these I'll be using the same thing, testing. Then for the train, it will be now no, it should be now test RMSE, and then same case to test mean absolute error, so that you can be able to see. And then we can be able to see also the overfitting. Overfitting, how can we calculate the first of all, let's see the overfit difference. Let's write also a check for that. Maybe say over fits underscore difference, overfit difference. Here it is going to be on the it's going to be now the R squared score for the training set, for the training, and then what the model has predicted on the testing. So the result will be getting, it will be now the overfitting. results. So here you can say, for example, if maybe overfit difference, if the overfit difference is greater than maybe 0.1, then we can say, for example, print out like the something like a warning possible overfitting, overfitting. Then we can be able to display the overfitting. I can use then formatted string. I can use the formatted string then difference of so I'll say overfitting, possible overfitting, then difference. Now this, okay, right, difference. So the difference here, it will be this one. We can also have it into 4 decimal place, because those individual values have some impact on the same. And then otherwise, if there's no overfitting difference of greater than 0.1, which means less, so equals or less, we're going to print, for example, something like let me say let me just copy this one. Let's say use something like this is good for generalization or maybe handling the unseen data. So good generalization to the unseen data, and then of course I'm going to pass in the overfit difference there. Then now we can be able now to print out here now in the new line now here. The new line now we can be able to give now the summary of everything now. So summary comparison, summary comparison, and then we can still, I can use it something like this one, summary comparison. For summary comparison, for the summary comparison, I say now model. To know which one is best, which one is not, a model comparison summary. And then here, what we'll be doing is we will, what did I do? Okay, like basically to use a print statement here, print. So here, maybe I can say in a new line, let me use a line break. So here, basically what we're trying to compare, it is let me use in a new line break here. And then basically what I'm going to do, sorry, a small new line. So basically here we have the model, model that is less than 20, a model which is less than 20, and then also we have also the test R squared, of which also less than less than something like 12, and then we can also have the what, let's have the test sorry, test kind of root mean squared error. So the test being the key, the value should be I think something close to 15 or so. And then also for the test mean absolute error, test mean absolute error, this one as well, less than 15, less than 15, and then we can be able to print. Let me have like this in this kind of a line, but then I can use a hyphen. I can just use a hyphen for that, and then we can be able to iterate using a for loop, for example, for name, and then also matrix in results, which we stored on that dictionaries, the results dot items items, and then we can be able to print. We can be able to print those metrics. Format a string. We're going to begin with the name of the model name, and then the one which is less than name, name less than 20 for the model column, and then the other one is okay. What I will do, let me just copy this stuff. So what I will be doing here is just to change now the matrix. Now from the matrix for the test R squared, it is in the matrix, the evaluation matrix. So going to be matrix is not a matrix, yeah, matrix, a matrix like this one, and then we'll be targeting the tests, for example, the test R squared, targeting the test R squared. So here it will be a test R squared, and then less than 12, and then of course we can be able to even have the those decimal. We can be able to have it to 4 decimal places. That's for the test, and then for the root mean squared error. I think I will use for the testing. Test root mean squared error. For the testing, it will be still in this metric, the keys matrix, then targeting the root mean squared error, which we can as well give it to for the root mean squared error, we can give it to okay, let's use 14 here, but then I'll use now 0.2 decimals, and then now for the test of the test for the, remember these units are in dollars. We're going to change in a moment. So for the test, this one again we're going to use from the matrix, mean absolute There's going to be matrix. Matrix, and then here's going to be as well maybe 2 decimal places as well. Testing. Then now remember the units are in these units, maybe these units are in dollars. Let me change it to dollar, and then for the test select error as well, let me have in the dollar symbol there. So, and then now for the to select now the best model based on this performance of these models. Let me write now a comment for that now in a new line. So to test or select now best model, to select now the best model. So best model is going to be now, you can just use the, so best underscore model underscore name. We'll use now the max of which we'll be checking on the results. And as well you can use a lambda function here, where key will be a lambda function, a lambda maybe results and then now the targeting the for the especially the squared error, the test R squared score. So this is what we are going to rely on for the so to choose the model. So we're going to just we are going to find the max, the one that has like the highest value there, and then now so the base model name, and then now the base model, like we can store it in a variable. So let's say base model, base underscore model. Now we are going to use models, then this model name, base model name, and then we can try to print out print can use a formatted string here. Then I can say base model, we shall display now the base model name, and the base model name, and then now for the R squared, so test R squared score. To justify that, we'll be using now the results. Base model score, model name, base model name, and then base model name, and then targeting the R squared error, R squared score, sorry, R squared, and then maybe you can have it into maybe 4 decimal. Yes, so this is for the summary, to select the best summary. So the algorithm, remember we have tried to incorporate several of them, so we want to see which one will give us the best results based on these data sets. Like to train this model in it, the one that will perform well, that's what we'll be relying on. Basically there I forgot on this where was it? I forgot to change. Where is it? Yeah, train. This should be test. I forgot. This should be test because this is on the testing. Testing. Let me run again this one, and then still we're getting the error on. Oh, print. There's somewhere I've written print in capital. Sorry. Oh yeah, here. Sorry. Prints. No. Prints. Yeah, I believe the bugs have been. No, not yet. Also on the lambda function, we are getting the error where the on the lambda function there we are getting the error that I wrote in capital. Sorry, should be small, and then results here. Let me run again. So guys, basically on these results, we can be able to assess from the very start. This is step 6 model evaluation. Then evaluation, the first one is the linear regression, and this is on the training set. Of course, it should be high. That's why you can see 91, 95, and then on the testing it is 91, 90. So which means testing it has performed well, slightly better. And then on the root mean squared error, on the training, of course, we expect it to be very high, which is 98. Okay, this is on the training 49. For 49,848. Then this is 49,757, which means on the testing it has performed even better than on the training set. And then on the mean absolute, this is 39,768. This is 39,647. Remember, the smaller it is on these other metrics, the best the model has performed. But then on the R squared score, the higher the value, the best the model has performed. And when you check on the difference on the generalization, it is good generalization. We say that anything that has, for example, greater than we say that anything that has, for example, greater than 0.1, then I will say possible overfitting. So which means that this one we can rely on the score. It is the difference here, it is 0.0005, and the R square score is 919. So which means that this one we can depend on it. Now remember, there are several other factors which have less impact. Those are the ones that are contributing to this kind of low score, but it's something still that we can be able to rely on based on the sample size and also the number of features. So it's something that we can be able to predict. And then now this is the score on the random forest. Random forest, it was 90. The R squared, it was 98. As you can see, it surpasses this one for the 91. But then when you try to check on the, okay, so these are the root mean squared error, mean absolute error on the random forest, and then on the random forest, and then this is like a no, this is on the training set. Actually on the training, of course, we expect it to be high, but then on the testing, actually the testing is what we are really assessing. So on the test you can see this is 89, so which means that this one of 91 is much better because this is 81. So it is not good at generalizing and seeing data. And then this one, as you can see, still it's not on the poor side, but it's not something that this one still surpasses it. The linear regression surpasses it. And then also on the gradient forest, so the R score on this one, it was 0.9099. So the difference here is 0.357. Now when you compare now 0.90, and then this one it is 0.91, then it means that the linear regression should be the one that I will go with, which means that mostly are following some kind of a linear pattern. So the linear regression model is best for that. So here now the comparison model, these are the results we are getting here. So as you can see, the linear regression has stopped everything. it has stopped everything. Remember, the smaller the value, the best it has performed. And then now, the best model the system has identified to be linear regression, and then it has given us the R-squared score. So which means that we are good to go. This means that we are good to go. We can rely on this solution, so we can be able to save it. So now, part 7 here, I want us to save this model so that we can go to the Django and then be able to build now the application for it. So, so this is step, is it step really 5? I think it should be something 6. This should be 6, and then this should be 7. And then now this one is now saving the model or serialization. So save model through serialization. So we need to save these solutions into something that can be transmitted can be transmitted from one app to another. So we'll need to have wait. Is it so this step 7? Let me say model serialization of the model, and then on this one, actually serialization, like this solution that we have achieved, we want to save it so that in future we'll not need to run everything again to retrain everything just to get a prediction. Is going to be very slow, especially if you have much data to train the model with. Is going to be very poor. So what we are doing is to save that solution and that model such that in future we just use that result, that model that has been saved, so that we can be able to go with it. So basically, we want to save the base model, not everything. We want to just save the base model here. So I'm going to say here, save the base model. What am I writing here? Save the base model, and then here maybe we can say model a variable model, maybe file name, model file name. You can get a variable for that, and then maybe I can use I'm going to save it on the same directory here. So here I'll just say, for example, house underscore price underscore model. So we'll be using the Pico library or module, which its file ends with the extension .pkl. It's a binary, and then also we need to also use the we'll also need to use the standardized data scale, so that remember, the people will just be keying the values. For example, the square feet. Okay, let me see. Let's see the original. See. So people will be keying this data. For example, the square feet. You can see the values are in thousands, and we had scaled them. So we need also to maintain that scalar, so that when we receive the response from the client side, we need to scale them to match with what we train the model with. So we need to save the scalar as well, so that you can use it. Scalar file name as well. We can just call it scalar, maybe scalar, and then .pkl. The Pico library ends with the extension. For the files, it ends with the extension .pkl. Then we can use the context management for saving the model. So it is shift. Okay, first of all, I want to create the comment. For example, or let me just use a print. Let me say print, and then I can use a formatted string here. Then I can say saving the best model, and then of course you need to specify the best model that we identified there with that variable the base model name, the base model name, the base model name, the base model name. So we can use the context management for the file handling that to write the binary. So we can use the with and then open. This is just basic file handling. With open is a key function to work with files. Open with. Then we are going to begin with the model name to save the model, the base model name, and then now we'll need to specify the mode. So by default it is always the read mode, but then this one we want to write, but it's not a text file, it's a binary, so we need to write binary. Then let's use it as an alias file, and then we can say pcall dot. Now to save no, so first of all this one, it is to create a binary file called pcall a house price model.pkl, so just an empty file. So if you want now to save the data into it, we're going to use now this pcall library, then dump method, dump method, and then we'll be specifying what we want to save there, or which should be it should be now the base model. The base model is the one that we identified here. The base model, which is the linear regression. So we are going to save that base model, and then you specify you're saving where you're trying to save on this file, which is the house price model.pkl, like that. And then maybe at the end of it you can write a print statement to show that it has been saved successfully. So let's say print model formatted string. Let me say model saved as and then we can use the file name. It will be saved like that way. Now I'm going to do the same on the also saving the scalar. For the scalar, actually for the scalar, let me say 7. Scalar, let me say 7. Scalar, this one we don't need even this one. Just say 7. 7 scalar. 7 scalar. So for this one we'll be using the scalar file name, which is the scalar.pkl. Also is a file, and then here on the dump we'll be using scalar. We'll be using the scalar. Remember what we did the other day, or like on the standardization, we saved it in the variable called scalar. So that's what we are going to save the content to that file, which is the scalar.pkl, and then the file name here on the scalar, it will be what? It will be scalar file name, this one. So let's say I change it to scalar. Scalar saved as the file name. Also, we'll need to save the feature names. We need to save the feature name. Remember, we converted they were in their what? They were in these names, but then now to train it to pass it to the model, we required the x and y, of which like for all the features we use the x here. We use the x. Then now for y we use, for like the response we use the y. So we'll need also to save the name such that if they will be coming, that's what we are going to use. So we can as well save them feature name. Save, or let me just write here, save feature names, and then now this one, for example, feature name, feature underscore names, this one I'm going to just use that x dot columns, of which is going to give us an array of columns. But then it will come as an array, but then now we can convert them into to lists, so that it can be like an array list. It can be like an array list, and then now we can use now the same logic we've been using here. So here, what I will do, I'll say, for example, this one I can be able to save, for example, the feature name. Let me write here so that no, not there actually. Let me just write it there directly. There's no need. So here I'm going to say, for example, the file name, maybe I can say feature underscore names dot pkl file, and then now the mod still it will be the right binary, and then now here will be here will be passing these feature names. It will be these feature names. So this is what we are going to pass there, and then the scalar will be saved as the feature names. Let me say feature names, saved as feature names, and then we can be able to as well save the model metadata. We can as well save the model metadata as well. We can save it as well. So let me write here save model metadata. So metadata, I can use a dictionary for that. Metadata, I can use a dictionary for that, and we are going to say first of all that base model. We are going to use the model name, model underscore name. We'll be using that based one, based underscore model underscore name. Now the reason we're doing it to make it more dynamic, such that in future, for example, if we try to retrain again and it finds like there's a new model which is performing best, then it's going to use that instead of the current one, which is the linear regression and stuff. So also the test underscore r squared, we are going to use, for this one, we are going to use from the results in that dictionary, I will be targeting the base model name, Then from that base model name, I will be getting its r squared. It will be test underscore r squared. Test r squared, and then now for the, let me do this, let me try to just duplicate, and then I'm going to, now remember it ends with the comma, like you separate them with the comma. So I'm going to say for the test r root mean squared error, still it will be the test r squared error, r mean squared error. Then also we have the test mean absolute error. It will be as well the test mean. It will be the test mean absolute error. Then maybe features. Now for the features, we'll be using the feature names. And then we can as well save the training sample. So training underscore samples. The training sample, I'll be using now the number of x underscore training set, which is should be now 80%. And then for the testing sample, now for the testing sample, let me say testing samples, it will be now the x test. Yeah, so this is for the metadata of the model, and then now we can use as well the context, which we are going to save maybe model. I'm going to say maybe model underscore meta data.pkl as a binary, and then here we'll be using this metadata as we'll be using the here we'll be using the metadata as the content to dump to the file, and then here I can say, for example, metadata saved, something like that. Metadata saved. There's no need even for this stuff. You can just say metadata saved, like the data about the models and everything regarding the models. And then of course we can be able to print out in the event. For example, we wanted to see some summary, we can even print out. Remember, some things I'm doing here, just they are not really necessary, but then for learning purposes, so that someone can know the best approach to addressing such things. That's why I'm taking my time just to explain this stuff very well. So maybe here I can say model training complete and everything. Model training, or let me use capital. Model training complete. Model training complete, and then and then maybe we can have, for example, say print then maybe print formatting, then I can say file, files created, then the first one was for the model, so print the files that have been created or serialized. The first one, maybe I can say user formatted string, and then some space, maybe one, it will be model file name. I think we use the model file name, yeah. Model file name, training model, train model has been saved. Let me try to duplicate. I think we have around 4 of them. So just a quick summary, and then this will be 2. Then this will be now for the scalar file name, like if it will be success, and then here will be say feature scalar, and then also number 3. And number 3 we can it was the names, feature names. And then here maybe we can say feature names, feature names. And then the last one that we've just finished is for the metadata. Metadata, this one, actually for the feature names, there's no variable for that, by the way. This one we wrote it directly for the name of the file. No, like for the feature names, it was directly, there's no variable for the feature names. Let me just do it directly here. Note, it doesn't require even this variable, there's no variable for the feature names. So I will just write it there directly. The same case too, the metadata file, it doesn't have a variable for the name. And then now here I'm going to just use it directly for the metadata. So this number 4, number 4, and then this is metadata, model information. Let me just call it model information. Model information. Yes. So let's try to run this code, and I will see if it's going to create those files. Should be creating them on this directory. Let me run. And then now the base model name is saying that it's not defined. It is not defined. Let's try to. Okay, it is on which variable? Let's see. Model name. Model name is saying not defined, and we had let's see. On the metadata, base model name, it should have been base model name. It should pick from this other side here, or this code is not. Yeah, let's run it. Oh, it wasn't run. Oh, we had not run it. Let me run now this one. Base model name. Why is not? How did I save it? Let me just find it so that I can even copy. A base model name. It is in the memory there. Base model name, and then base model name, and then here on the metadata. This is actually what I'm trying to pass here. Model name is base model name. Base model names. I don't understand why it's not. Oh, all right. Yeah, so I've seen the problem. I used model instead of model. Yeah, sorry. Uh-huh. Let's run and see. Yeah, wonderful. So these files have been saved. So saving the base model, which is the linear regression, saved as the house price prediction. So saving scalar, it saved this as a scalar.pkl. Then for feature names, these are the feature names, and then the model metadata was saved. Then the model was complete, and the files we have them here. Now it should be 4. Yeah, 1 for the scalar, and then for the this is scalar, and then there's a model. Where's the model? And this is for the model, then for the feature names, and then for the metadata. So guys, finally we are good. We've trained our model, we've saved it, and we are ready now to create a graphical user interface for a user to be able to see and interact with our solution. So guys, basically for the Django, we are going to, okay, this is what we are going to do. In fact, now that we are done with this part, we've saved everything. We can even close this part. Yeah, so guys, basically I want now to structure my folders very well. What I'm going to do here is to open out the Visual Studio Code. Now we want to build now the server-side app. So what we are going to do, you need to have Visual Studio Code. If you do not have, go to VS Code, download, just search for VS Code, download, and then find the link there, and then download for your operating system. So it's just straightforward. What for me I'm going to do, already I have it, so I'll launch it. And then the first thing that I usually want to check on VS Code is if I have this feature enabled, the autosave feature, so that when I write the code I do not need to be always saving manually, so it's going to automatically save. Now that this one is configured and everything is ready, the theme and everything, so I'm going to open now my project which it is in the YouTube courses, and then now the house price prediction. So basically on this one, I'm going to do this. I'm going to create now the backend. Maybe I can just create a folder. Let me create a folder called backend, because I'll have also the front end. So let me create a folder called backend. And in fact, this train test, let me just put it to the backend folder. Yeah, this is fine. Then I'm going to open my CLI, and then what I'm going to do is to create a virtual environment so that this project is going to run on a virtual environment, so that all the dependencies will go to this application, but they're not on the system level, so that we can be able to even freeze the requirement. Yeah, so what I'm going to do now is what I'm going to do here is to create now the virtual environment first. So it is Python dash. Now the CLI. First of all, let me show you how I was here. So first of all, once I've imported the folder, I created the backend folder. Then I pulled this train test folder to it, and then I click here on the terminal. Then a new terminal. Then it open mine by default the CMD. But then we don't want to use that virtual environment that it came with, so we deactivated. Once again, let me repeat. You go to the terminal, then you click. Now it's going to come activated, which is like the system environment variable. So what I'm going to do is to deactivate it. Now I know for you maybe it cannot show this one, so you don't need to do this. Deactivate, deactivate, and then CLS, if you are on Windows, to clear the history here, not deleting, just clearing. But then if you are in terminal, you can write there clear, the word clear like this. But then now on Windows, on this command prompt, I'm writing CLS. And then what I'm going to do is to create the navigate first of all to the backend folder. So cd backend. And then once I'm in the backend, so I want to create the virtual environment. So I'm going to say Python dash mvenv, then the name of the environment, so for example env. So when I run it like that, then it's going to create the env folder inside the backend folder, because that's where the virtual environment is going to that is like the environment where this project is going to use, like in terms of the dependencies and everything will be listed on that or installed on that environment, including the running the application and all that. So now once I've done that, then I will need to activate the virtual environment for this Django app. So env backslash, and then env is like this folder, then backslash is this. I want to go to the script folder. So scripts, and then backslash, I want to use a file to activate, which is activate.bat. So activate.bat. So env scripts activate.bat. Now this env is like the name that I gave for the environment variable here. Yeah, so when I run, you'll see something will change here at the start. So this tells me that it is activated like this. And then let me clear now that I'm under the activated virtual environment. And then once I'm there, I'm good to go. So the next thing I want to install now the dependency. We are going to install Django here, so it's going to be listed in this lib. So let's try pip install Django. So it is pip install Django like that. Then when you run, it's going to be installed here. So this is the advantage of the virtual environment. It doesn't go to the system; it goes only to this env folder, so that once it's there, it can be even easier to freeze the dependency, such that remember this project you are developing on your local environment, but then you might want to deploy it on the cloud. So sometimes you find that you are telling the client it's working on my computer, yet on the cloud it's not working. So like those kind of issues, freezing those requirements, it allows you to deploy the same configuration or the same dependencies that you are using locally will be the same with specific versions also on another environment. So how do you freeze those requirements that you have installed? You can use the pip freeze, then to a file name, maybe we call it requirements requirements.txt, pip freeze, and then at this angle bracket for greater than, then requirements.txt. Now when I will run, you'll see it has frozen the requirements that is Django, and then these are the dependencies. So which means this is what the project really needs. Like this what the at this time when we're creating the project, is using these dependencies. So in case it works, then these are the configuration that will have been used for that. So now the next thing, now I want us to create now the project. So to create the project, now once you've installed Django, to create the project, you'll be using now the Django hyphen admin, Django hyphen admin, then a start project. And then this project, maybe because this is where the settings are going to be placed, maybe I can call it config, or just call it project. Let me call it config, start project, then config. Then I want to install it here, the root directory. So I'll add in there the dot at the end, which means that I want to create it here, the root directory of this backend folder, so that I can have that manage.py as well here. This is very key because this is what we'll be using most of the time now from now henceforth. So once you've done this, then I want us to install not installing, actually I want us to create an application for the prediction system. So prediction app. So let me say now we'll be using this virtual command line. So I'm going to say Python and then virtual command line, which is manage.py, then create is startup, I think start app, then app name, maybe we call it prediction. You can give it a name. I think I should call it I think let me just call it prediction. Let me call it what name can I use, guys? There, I wish this session could be live, so that I can be getting some comments, some feedbacks in the comment. But then you can as well give a comment with this just to increase the engagement on the video, and also it can help, for example, to like reach someone else who might be interested in this stuff. So make sure that you're also helping me on maybe commenting. For example, if the project is good, you can say the project is good, or if it is bad, you also say it's bad, or maybe if you need some clarification somewhere, you can as well say there, so that I will reach out and then be able to assist you. So the app, let me just call it predictions, and then it's going to create the prediction apps here. So once you've created, you need to list it to the app config. So I'm going to go to the this list of installed apps, the list of installed apps. Then I'm going to say prediction, prediction, and then I can include it here on this project URL. This URL folder here. I'm going to include the URLs as well there. So you'll say now from you can have the path, and then as well include from these Django URLs, and then I can say maybe path. Okay, first of all, let this one be pending first. We are going to create it, and then we shall configure later, because it's going to give me the error that it hasn't been configured yet. So we have included in the project setting. So the first thing that we want to do now, okay, by the way, we are going to require also the REST framework to create the APIs for that. But before that, let's begin to work on the models. On this prediction, there's a file called models. And then this is where I want us to create the model. It's going to be very simple here. So let me just call it a class, and then our prediction is to, let me call it prediction. Remember here we're just saving what the responses, what the model is going to like to predict. Like it's going to give it, like the user will be keying some data, then the model I will be giving out the response. So we'll need to save that so that in the event, for example, we'll need to retrain the model as well. We'll have the data for that. So prediction history is going to just be a simple one. So this one we're going to just use the normal model, and then we want to store the prediction history for analytics or stuff. And then here we can wait. These models, yeah, yes. So for the remember these are the let's see. Okay, I deleted, but then we had the we had several features on it. If we can just open this one, so you can see we have the square feet. I don't know if this is possible to just copy this stuff, and I don't know if it can be possible. I'm trying to do something here, which yeah, this is wonderful. This is wonderful, yeah, because I didn't want to be writing. So let me just have this one, bathroom, bathroom edge years, and then there's a garage space. Of course, I'm going to assign some values to them. Garage spaces, lot size. These are my column names. Then there's a floors. Then there's a crime rate. Then there's a score rating. Then there's a distance to city miles, and then there's a house ports, and then it also has a house fireplace, house renovated. So these are the details will be 7. Then a neighborhood quality, and then a predicted price, and then as well we are going to have the created art, like a okay, sorry. Oh, the house house. So this price actually we can make it predicted, because now this what is so this one I can say predicted predicted underscore price, and then we can as well have the time the model was created, the history was created, so created underscore art. Now remember, this is just column I've listed. I need to assign some values to it. Now I'll be using now models dot integer field in fact, for all of them I'm going to use just the integer field. So I'm just going to copy, and then I'm going to I should copy also with the equal sign. All of them, they are integer field. Integer field. Bathrooms also, it is integer field. Age year as well, it is the integer field. And then the garage space will be the integer field. Then the square feet also, it will be the integer field. And then these are floors also will still use the integer field. Then the crime rate as well. For the crime rate, because this for the rate, we can use maybe a float field, because this is like at the rate. And then for the for the score rating, this one we can use the integer field. Then a distance to the city in miles, this one we can use the models. Sorry. We're going to have an equal sign first. Models dot float field. Let's use the float field in this one, and then has pool. This one is a boolean, right? Has pool, or maybe let's just use the integer field where I will be using 1 to represent yes. And I remember it was like it was kind of encoded it was encoded. Then a has fireplace, also it was encoded. Let me just confirm here. So you can see has pool, it was encoded 1 to represent yes, 0 to represent no, like that. So we are still using the integer field. And then a has renovated, we are going to use the same thing. The neighborhood quality, we shall still use the integer field there. Then the predicted price, because it varies, so we can use even the float field. So models dot a float field for the predicted. And then now for the created art, we are going to use the time zone. So models dot date field, no, it should be date time field, because we need to record that one. And then we can use the auto now art, such that when you be creating the history, it automatically create that time that it was created. So this is it. And then now for additional class here, we can be able to say we can be able to add in some model behavior like ordering and a plural name for this one, prediction history. So we can use a class meta so that we can be able to configure models behavior like on the ordering of items. So we can say class meta, we can say ordering, and then we can use the created art, but then the latest first, then for verbose name underscore plural, this is let's say, for example, prediction, histories, prediction history. I don't know if that's there. Prediction, I think that's this one. Awesome. Histories, and then the string representation of the object. Now remember, this one I will assume you have some skills in Python. If not, I have created the sessions for that as well on this one. So here I'm going to return now the formatted string is going to be okay, like at the strings representation here, I'm going to use maybe prediction, the prediction in terms of price. Maybe we can say now, we can say, for example, self dot predicted price. Maybe say predicted price into some true decimal place, to decimal place. It should be dot decimal place, and then and also the time that was predicted. So it will be now self dot created at. So self dot created at. So guys, in a nutshell, the model, these are like now tables in a database. Like the information which we'll be receiving from the front end, we'll want to save them in the database, so that in case, for example, we want to retrain the models in future, we can be able to do that. So this is on the models, but then now we are going to require to kind of serialize. We'll need to serialize these models, because we'll be we want to create the APIs. So these tables are in rows and columns, and if you want to transfer this information, or maybe to share this information to the client side, then at least you need to convert it to something that can be transmitted, like a JSON, XML. So by default, we're going to use the REST framework, of which is going to use the JSON. for the responses to send to the client side on the API. So we are going to require a file called the serializers, so that we can save these models, this information, serializers.py. We want to save this information as I want to save this information as in a different format, in JSON-like format, and for that we'll require the REST framework, PHP Django REST framework, PHP Django REST framework. So we are going to install this one. We are going to install it here, and then remember, anytime you're going to install a dependency, you'll need to freeze it so that you don't forget in case. I will need to freeze it to these requirements once it is installed. So I can use this command for freezing, which is php freeze requirement.txt, and then I will have the REST framework. So once you've done so, you need also to configure it to, you will need to configure the REST framework to the list of installed apps here on the config. So comma, and then here we are going to write here REST underscore framework. Actually we installed it this way. Actually we installed it this way, but then how to use it? To use it, you need to use it in this format. In this format. In fact, let me just copy. In the list of installed apps, we'll use it this way. And then also we're required to add it to the middleware. You can see here, I will need to add the REST framework to the middleware. Sorry, let me find the middleware. Is there any REST framework? It's not, they haven't like listed it there, but then we need to also this, let me just have it, though I'm going to change some parameters there, but then just the variable, let me have it here. Now in the middleware we'll need to add in the actually for the REST framework we really don't need that one. Maybe we can try to add in on these let's just work on these classes only, the REST framework, these variables. So the classes that we are going to use, the default, let's use the default renderer class. Default underscore renderer. Is it written like that? Render underscore classes. On this one, we are going to use on the set of the value in this list. I'm going to just list one. Actually, we're going to just use the REST underscore framework. REST framework dot renderer dot JSON render JSON renderer like that, and then for the parser classes, so default underscore how is parser written? Parser underscore classes, parser classes. On this one we are still going to use the list, and then here is going to be now REST framework, REST in quotes, REST underscore framework, and dot parsers dot parsers dot JSON parser, JSON parser like that. Then we are good. Actually, we have configured the REST framework very well. So now on the serializer, so we're actually going to just import the serializer. So from the REST framework, REST underscore framework. I don't know why it's not detecting automatically. Framework, REST framework. I want us to import serializers, and then we're going to import also the model that we've created here so that you can serialize it. So from the current directory .models, import the we're going to import the prediction history serializer, and then we can create now the class for the serializer. So class, we can say house features serializer, house features serializer. On this one, from serializers, we're going to use serializers. We're going to have the serializer, and then now from that we can be able to validate the input data for the prediction for this purpose. So maybe what I will do is just to copy like at the features. Let me just copy this stuff. Let me just copy. Then I'll just be changing to serializer. So I have them here. So now what I'm going to change here is to from the integer field, like from the this model, I'm going to just change them to I'm just going to change them to serializers. Of course, here it should be model. Yeah, so once it is serializers, and then the integer field, a float field, but then now here we'll be adding some parameters in the inside. So like here, maybe we can have the by the let me select all of them again so that I can try to do it like at a go. So here in the inside, I'm going to say the mean value, mean underscore value for validation, mean underscore value. We can say, for example, 100, and then a max underscore value. We can have, for example, around 1,000. Now remember, this is on the square feet, but then now we need to update for the bedrooms. Maybe this one, like one bedroom, can't go beyond 0, and then the maximum maybe 10 or something, and then for the bathrooms, at least it must be 1. Bathrooms can be 1, and then max we can have around how many 10 as well, maybe. And then as well for the age years, it's between the age years maybe between 0 and then, which is like at the latest one, and then maybe 150. We know there's not a house that is older than 150 years, assuming. And then also here on the garage space, you can sometimes not have a garage at all, and then you can have as many as you can, from maybe to 5 or something. For the garage spaces, maybe you can have to, for example, for 5 or something. And then for the lot square size in you can have, for example, the minimum to be around 500, and then now the max can even go the way to let's say even 50,000 for the lot size, and then for the floors from 1 all the way to 5, or 1, or maybe all the way to, let's say, again, here in Kenya, most houses can even go all the way to seventh floor, a residential one. Can even go to 7. So let's give it 7. And then climate area. Sorry, not clear. It is crime area. Crime what? Crime rate. Sorry, crime rate. Crime rate. It's a float rate. It's a float field. A crime rate. Where is it? Oh yeah, it's a float field. So this one we can give it 0.0 and then maybe to 10, right? 0.0 or maybe to 20, to what? To 20. 20.0. And then now for the score rating, maybe between 1 and 10. Mean 1, then max maybe 10. Max to be 10. And then for the distance maybe is a float. Sorry, what is that? This one, the distance to is a float, so maybe it could be 0.0 distance, and then now the max, it will be you can specify any max. For example, the distance to maybe you can say 100. I think there's nobody who can say 100 more than 100 miles to the town. Maybe they are working there. And then now a hash pool. Now remember, this is a float field, so it needs to have the decimal. No, this thing, and then we can also have the we can also have so for the hash pool, this is an integer field, so maybe 0 hash pool. Let's say, for example, 0 can neither and not have sometimes even a pool, and then maybe you can have, for example, 1 or 2, and then maybe hash fireplace. Place, maybe it is 0 to represent the snow, and then 1 to represent this fireplace. By the way, even this one, it is 1, not 2. Remember, this is 0 to represent hash pool, yes, and then do not have how it is 1, so you shouldn't surpass that. And then remember, it was encoded from yes, no, things like that. So and then now neighborhood quality is renovated as well. We can give it 0 and then 1, and then for the house quality, maybe this one we can say neighborhood quality, it ranges between 0 or 1 to 5 being like this good neighborhood quality 5-star. And then now the prediction response. Let's also have the prediction response class for that. Class is going to be prediction. Prediction maybe response to send to the user, response from the model, response serializer. Serializer here will be using still serializer. Serializers dot serializer serializer, and then basically on this one is going to be very simple. Here we just need to have the predicted from the model predicted price. Predicted price will be using now the serializer serializers dot float field and then model name it will be serializers dot This will be a character field, character virtual character field, field, and then we'll need also the confidence score. Confidence score. Confidence score. Here it will be serializer dot. It will be a float field. I think yeah, float field, and then features used. Features underscore used. We'll be using the serializers dot. This one can be a dictionary. Let me use dict field for dictionary, dict field. And then yeah, so I think for the response we just need to have the predicted price, and then the model name that has been used there, and then now the confidence score, and then now the features that were used there, and then now for the history, to show the history, we can be able to have a class for that as well, because it's saved in the database. So prediction history, serializer, prediction history serializer. Basically here I'll just be using serializers dot model serializer. Actually serializer, let me just model. This one I'll use the model serializer, serializer. Just hope the name is correct. And then on this one, actually, we are going to just like use the model serializer, where you need to specify these behaviors on the meta. We say now model. In this one, we'll be using now that prediction history, and then our fields. Our fields here, you are going to just use all. So you can use this underscore all underscore to get all the fields there. Yeah. So guys, I want us to go to the other part, and first of all, I want to create within this prediction. I want to create maybe a folder where I'm going to have all these models that I've trained on it. So maybe I can create a folder within this predictions app. I'm going to create a folder called ML underscore model underscore models. ML underscore models, and then on this other one, I'm just going to copy the files. I'm going to copy this scalar, I'm going to copy the metadata, I'm going to copy this one, I'm going to copy this one. These are the ones that we really need, and then I'm going to paste on this ML models. I'm going to paste it there, and then yeah, so we are good. So even right now we can be able to delete this file, because we have what we really need, but we want to retain that notebook, so that in case, for example, you need to update or something, we'll be able to do so. Now what we are going to do next is now to I want us to create some kind of the ML, the machine learning service. So let me just call it ML underscore service dot py underscore py, and then here, because we're going to require now the pickle library too, so I'm going to say import pickle library. We're going to import the pickle library for deserializing now, for loading those models that we saved. And then we can import also the OS to get the path, import OS. And then we shall also require pandas. This one we will need to install it. Import pandas is PD alias. Then we shall also require, PD, PD, I don't know why, S, import pandas S, PD alias. No, I don't know why when I try to type. Import pandas as PD alias. Then we shall also import from Django.config.conf. We're going to import settings. We're going to import the settings. Now, what we're going to do is to create a class. Let's create a class here called ML model service, the class. And then this one actually is going to handle the machine learning model loading and also the matters prediction. So let's have the instances. So instance by default is going to be none. Instance, I want to give it a none first. A none, then also underscore model, we are going to give it none also. We're going to initialize it with none. And also underscore scalar, again we are going to initialize it with none, and then also the metadata as well. We are going to initialize it with with none. We are going to initialize it with none. And then so for the new, so let's create div, and then we're going to use now underscore new. We can say, for example, if CLS dot is dot instance is none, then we will say CLS dot underscore is instance. I'll be using out the super function now to give it to, so super, I'll be using out the super a method here, and then I'll be initializing this ML service. Now basically what we want to do here is to ensure that the model is loaded only once, so that we can also save the the memory and also the time that's going to be used to process those things. Yeah, so so we are going to load it once. So here we are going to also have the CLS, and then dot underscore new, then CLS like that, and then CLS, which are CLS dot underscore is instance, and then we are going to implement a method. We're going to implement a method that's going to load the models underscore load underscore model. We're going to implement this one models in a moment, and then we'll be returning return CLS dot underscore instance, and then now let's try to implement that method now. We shall say diff then underscore load underscore model underscore model is a method, so we need to install self and then here, so for the base part, for the base underscore part, let's use the os dot path dot join then which we can pass in the inside now the base part, the base part. Oh, sorry, not the base part. Actually, we'll need to have the settings that we imported up there. Then I shall use now the base dir from the setting dot base. Let me just what I'll do. Let me just go there and then just copy it directly for the base directory. Let me os path join then setting dot base dir, then for prediction predictions, and then ML models, ML underscore models, ML models. Then we can use some exceptional handling here. We can say, for example, try. This is an exceptional handling. So try, and then let's try to load now. Let me say load model. So here still we are going to use now the context. So with open, then in the inside we'll be now using the os.path.join and then here we'll be joining now that base part, the one that we have defined up there, and then we'll be using the house underscore for the file name, house price model, house price underscore model dot pkl, and then we need to specify the mod as well here. So right here, comma, then the read binary. So now here will be reading, and then read binary, and then we can use it as an alias file, and then here we shall use now self dot underscore model, which was initially empty. So this time we are going to use the pcall dot load. Now this time it's not dump, it is load. It is load, not loads. Load, and then now we'll be using the file. In fact, let me use F for file, like I stand for everything there. Then I'll be loading now that file for house price model.pkl. So this is for the file, and then now for the scalar, let me say load. In fact, let me just duplicate this one. Let me say load scalar. Now for the scalar, basically what I will do is just to I'll just change the name here to scalar. Scalar, still it will be a read binary, and then as an alias f. Then for the feature names, let me say load feature names, features, feature names. Feature names, it is feature names. It's feature names the way it is. So here I'm just going to change here to. I'm going to just change there to be feature underscore names .pkl, then a read binary still is an alias, then here will be. Now, okay, what I forgot here, this is not for the model, this is for the underscore scalar, for the scalar, and then this will be now for the underscore feature names. Feature, did I create a variable for that? For the this one should be now for the feature. I didn't implement that one. Oh, I see. Let's also have maybe underscore feature underscore names. Also, I will initialize it with none. With none. Then here feature names, I'm going to say feature underscore feature names. Yeah, feature names like that. And then so basically for the feature names. Then now lastly for the metadata. Now load metadata. Let me say load metadata. So for the metadata, I will just change here to what was the name? Model metadata. Metadata.pkl, and then for that one we'll be using underscore metadata. Yes, so once we have saved them, we can as well have a print statement just to see. So we can say print print, and then in this print statement we can say something like model ml models loaded successfully. ML model loaded successfully. As well, we can remember this just for debugging, and then also we can say the model. I can use a formatted string. We can say, for example, model itself. Then on this one, we'll be calling that dictionary self dot now metadata. The metadata of which I will be interested in the test R squared. Then of course we can make it to be in the 4 decimal place, decimal place, and then wait. So for this, for the model, let me be descriptive. Maybe I can say model, but let me just say test R squared score, and then maybe you can have the name. By there, it's also good you do that. So let me say print, so that you can know the model that's being used, which is very powerful model. A model name, or maybe let me just say model. So for the model here, we're going to use underscore. Okay, first of all, self dot underscore. I will need to begin with the formatted string, the underscore, then metadata. But then on this metadata, I'll be targeting now the maybe the model name. Let me say model name. Remember we passed it name in that dictionary of the metadata. We have the model name. So I think now when it will give us some score, then we'll be good to go. Now these are try. So we need to implement that the except. So the except should be here, I believe. Yeah. So here I can say except. Except here we're going to use the exception. Exception is an alias key, and then I can say print formatted string. Let's say error loading models. Error loading models, and then we can be able to display that error as a string, and then the exception as a string. Yes, like that. And then we shall raise also. So raise the error. Yeah, so basically this is to load the models of which we shall be passing on this instance. Now the other thing now we want to implement now for the prediction. So for the prediction, I'm going to create a method for that. So div, then let me say predict. Predict, and then on this predicts we'll be requiring the features dictionary, which will be coming from the front end. So features underscore dictionary, features underscore dictionary, and then on this one we will definitely need to convert those dictionaries into a pandas data frame, of which will be receiving from the front end. Actually, we want to make the prediction from the feature dictionary. So what we'll do, let me try. Let's say try. Then maybe we can convert to the data frame. So features dictionary features. Let me call it features underscore df, the variable. So on this one, we are going to convert that dictionary to a pandas data frame. No, actually should be features df should be pd dot data frame, a pandas data frame, and then here we'll be passing what the dictionaries. Will be passing the we'll be passing the features dictionary. We'll be passing the features dictionary, and then I will be targeting the features names. So self dot underscore features name, feature names like that. And then also for the scalar features, we can call it, for example, features, maybe I call it scaled, features which are scaled. So here I will be passing them under the self dot underscore scalar, and then I'll be using now transform scalar dot transform, then features data frame. Features data frame will transform them into features data frame there. And then to make prediction, I think we could have some comments there, but then because of time, let me just say make underscore or maybe let's say predicted price, predicted underscore price. So for the predicted price here, we'll be using self dot underscore model underscore, where's the model, underscore model underscore a model, and then I will be using now the predict from the sklearn predict, and then what will we be predicting? I will predict now the featured scale, which are scaled to match with what was trained with, like what was trained, and then I will be targeting the first index, which is now 0. Remember, it is a data frame, so we'll be targeting now the first array like that. Then we can also calculate the confidence. So confidence basically here what we will do is can use self dot underscore metadata. Now from the metadata I will have stored the score of which it will be in the it will be test r squared test r squared score, and then we can be able to write the in the return here. I'm going to return in form of a context, in form of a dictionary, where predicted price predicted price is a key. Then the value, I'll be converting it to a float, because we need it as a float. Yeah, so we'll be using now float, and then we'll be passing the predicted price to convert it to a float. And then the other thing, we are going to require the model name. So let me find the model name. So for the model name, let's try to create also for it model underscore name. Basically for this one, I will be getting it from the metadata, so it will be self dot underscore metadata metadata I believe. I don't know why it's not yeah, so metadata, yeah, this is fine. And then metadata, and then I will be extracting the model name underscore name. And then the other thing, we are going to have the confidence score. So for the confidence score, confidence underscore score score, this one it needs to be a float. Then this float basically will be just using that confidence there at the top. Confidence, I'll be using the confidence, and then the other thing we are going to, like the features underscore used, we're going to use the features dict features dictionary. And then I think those are the information we require on the context for the response to the client side. And then on the except on the except, I'm going to use the exception as an alias E. And then what we will be raising here, so let's raise the exception, raise the exception, use a formatted string here, and then I can say, for example, prediction error, and then we shall be able to display the error that we had stored there, but then in form of a string, str, to convert it to a string, and then I will be passing that exception, the exact exception there. So this is for the prediction. Then now to get the model, let's have a method for that to get the model. Now to get the model, what we'll do, let's create a method for that. Get underscore model model underscore info. To get the model information, we'll be using now the self, and then here basically what I'll do, I'll return let me copy this. Let me copy this. Let me just say return, and then we are going to return first of all in form of a dictionaries. So, not a dictionary, this is a return statement. So the return here, we are going to require the model name, of which we'll get it from the metadata, which is just a model name here. This is what we are going to return, and then also we'll need also the let me just say it. We will require also the test r squared score underscore score, and then it will be self dot underscore metadata underscore, from the metadata will be taken the test underscore r squared, and then for the these things I could have just copied from the other side. So then let me just, it's fine, let me just say here this is root mean squared error. The root mean squared error, basically on this one I'm going to use root mean squared error as well for the metadata. Forgot to add in the comma here. Now from the metadata we'll be targeting the test underscore root mean squared error, and then mean absolute error. I will just change here to mean absolute error. Which I shall just change here to mean absolute error, and then here it will be now the test mean absolute error from the metadata, mean absolute error, and then also we will require, in fact these parameters I could have even just copied from the other side where we implemented, instead of repeating again and again, but then it's fine. We can have the training underscore samples, training samples. This one I'm going to use from the metadata, we saved it there, self dot underscore metadata, and then I will be extracting the training underscore samples. So we saved it the other side, samples, and then lastly we can also specify the features. You can be able to return the features. So features will be self dot underscore feature names, feature names. Now there's something. Let me just confirm if everything is really fine. Okay, so for the features, data frame to convert it to the correct column orders. The correct column orders features dictionary cell dot feature name is fine. Then for scale features, so it is features dot scalar that transform, and then a feature div, and then to make prediction, so the predicted price self dot underscore model dot predict. Then no, actually here should be featured. In fact, I've done well to review. This will be predicting based on these are scaled features. This is where we are going to predict with. Sorry about that, I forgot. And then now the confidence. This is from the metadata is fine. Then this is what we are returning. I think this is pretty fine. Now, so this is for the service. In case we see the bugs, we'll be able to fix it later. But then I want to implement now the views for the API endpoints, where they'll be making now the calls. So on that one, we are going to have several, I think a few endpoints. So from the views is where we're going to do that. So first of all, in this one, we're going to, let me delete first of all the current content. So we're going to say from REST framework dot decorators dot decorators. I want us to import API view. Yeah, this is fine. And then we are also going to from again REST framework, REST underscore framework. We are going to, but then from response module, we are going to import the response class. Response. So this is what we'll be using to send the user, the client side, the response. And then also we are going to import status. So from REST framework, we will require the import status to be able to see different statuses. For example, 5,000 error, 4 not found, and all the other errors. And then yes, and then now we are going to, let's also import now those serializers that we implemented. Now from the current directory, serializers file, I want to import house features serializer. We can also import the predict history. No. This was predict history serializers, and then we had also the prediction response serializer. So these are the serializers, and then also we'll also need to have the so from the current directory models, we are going to import the predictive model. Then from the service, from the current directory, then ML service, this file, we're going to import that class, import the ML model service. Yes, so this is fine. So we can be able to initialize the machine learning model class. So here I'll say ML underscore service. I'll just initialize that ML model service. Doesn't have any argument, any property or parameter or something. So let's have it like that. And then we can be able to we can be able to decorate the endpoints here. So we can use that API view, the one that we imported earlier, as a decorator, and then the method. So in the inside, we are going to specify the method for predict. This should be a post. We'll be receiving information from the client side as a post, and then once we save it, then I will be able to predict. So here, let's say, let's create a method for prediction. Predict, no, is a method, is a function. So let's say predict underscore price, predict price. Here we'll be receiving the request from the client side, request, the post request from the client side, and then what we'll do, we can be able to we can be able to first of all validate the inputs. We can be able to validate the inputs. So we can use the we can be able to, let me say, serializer. So will be, once we receive it, then I will be validating it on the serializer of which it was on this other side. The house features serializer is going to validate properly, including, for example, this min, max value and stuff. It's going to make sure that oh wait, sorry, this should be values. I think of values. This fine, and then continuing to the setting here. So we'll be using now that we'll be using that serializer for the house feature serializer there. I will be using now the house feature serializer house feature serializers, and then which I'll be passing in the inside the data will be the request dot data, which the request is the information that I will be receiving from the client side, and then I will be getting out the data, and then now this one is going to validate it, sorry, and then if not serializer, if not serializer dot is valid, if the serializers it's not valid, the one that it will be trying to serialize it, if it's not valid, then we can return an error. So return to the user, return response, let's say response let's use a dictionary here, where I'll say error, like here, error, and then error, and then the error name may be, for example, invalid data, or input data. Let me say input data, and then now on the details, comma first, then details, I will use the validation from the serializer. So it will be serializer dot error dot errors from the serializer. So it's going to catch the errors, and then we can return the response as well, maybe internal. No, this one it will be a bad request, right? So status here. This will be using our status dot this will be HTTP a bad request, which will be 400, right? This should be 400 bad request here, a bad request, and then if, for example, it is valid, if it is valid, then what we'll do we can process. We can also go to the exception handling. So we shall try. So features. Now features, if it has been validated, then the features I will be using the serializers, serializer dot validated data. I will be using the serializer dot validated data, and then prediction result will be I will be using from the ML service, which we instantiated earlier. So we'll be using the ML service, and then now predict, and then what we'll be predicting here, it will be now the features. It will be features of which is validated. It is validated in the serializers, and then this one is going to store the predicted results, and then once it has stored, then we can also save it in the database. So we say prediction, not price, but then prediction underscore history, prediction history. We are going to use the prediction history model dot objects dot create, because this is a new one we are creating. And then what will we be saving there? I will be saving the features, so which it is everything there arbitrary. It's going to save features in form of keyword arguments, and then predicted price. Predicted price is going to be prediction result, prediction result, and then prediction result, prediction price, actual prediction price, prediction result, prediction price. So that's what we'll be storing there. And then yeah, so basically for the prediction result, because this is what we need to save to the model. This is what we need to save to the model, the prediction result. Remember, prediction price is what we are saving from the model that has predicted. We are saving it here now and there. This database. And then once we have done so, then we can now try to format the response for the user. So let's say response serializer underscore serializer. This response serializer, then I will be using that serializer, the predict response serializers for the user now to be able to see it. And then now what will we be passing there? We'll be passing the prediction result, the prediction result, and then now the response okay, let me do this. Let's just return directory, because you have already let's say return. Now for the user, we'll be using now the response, and then what we'll be passing here, it will be now a success, not the error again. Success, we'll give it to be a true if it was success, and then the data, it will be the response serializer dot data, and then the history, history underscore ID. History ID will be storing from the prediction history dot ID, and then the response will be returned. Now remember, this should be in a dictionary. Sorry, I forgot. This should be in a dictionary key value pair. In a dictionary, and then the status here. So status here will be status dot. Okay, I forgot this one. This one. So status, it will be status dot http 200. This will be http 200. Okay, which means it's okay. And then now in the event, for example, there's an error somewhere, then we should be able to catch it under the cache. Wait. Let's see. Oh yeah, it's fine. We shall use the except, and then as an exception to capture the error. Exception is an alias here. Then I can say return. Can we just use this one? Let me just use this one. So on the response, we are going to return error, and then now the error may be prediction failed. Prediction failed, and then now the details here will be using this str. The exception there is E, and then we shall return status here to be 500 http 500. Let's find 500 server error, and then now server error. Yeah, so that's the response that will be returning. And then now for the model info, let's also have the API endpoint for that. So API underscore view, and then at this one it will be the get. The user will be receiving those information now. So here it will be get and then so basically here we can just implement now the exceptional handling directly. So try, let me say try what is it going to try? Info is going to be ml service dot get model info, get model info method, and then once we have it, then I shall return the response in form of a dictionary, where it will be a success, and of course we give it true, and then now data, data. So for the data here, it will be the info, it will be info, and then now the status. So here, comma. So let me say status. Here it will be status. Status dot 200. Where's 200? 200. Okay. Others exception. exception. It will be, we'll be using now exception as an alias here, and then we can return. Let me just use this one, but I'm getting the error somewhere. There's an error somewhere. Let's see. Okay, we forgotten to write the function. Sorry. So div, and of course this is not like a, yeah, so it doesn't need that one. So here we can say model underscore info, and of course we'll be receiving the request, and of course now it needs to have this at the end like that. Yeah, so that's what we had forgotten to have. And then now so guys, basically what we are going to do next is let's try to implement the prediction history model. So again, I'm going to use the decorator for the API view so that we can make these endpoints a URL. Although we need to I will need to as well update the URLs later, but then we want to make like the views to be at the same time the endpoints. So on this one we can say model history div model sorry let me call it prediction underscore history prediction history, and then here I'll be passing in results. I'll switch now the request from the user. Now remember, this should be a function. And then here basically I'm going to use the exception handling here. So I can use a yeah. Let me try with try. Then on this try the limit, I'm going to use I'm going to convert it to ints, and that's the request. Sorry, this should be a request. I don't know why I wrote result. This should be a request from the user request. Now here it's going to be now int request dot get get method, of which here we will be limit to 10. We shall limit to 10, and then predictions and the prediction actually will be using now the prediction history model, and then on this one it will be dot objects. We want to see all the objects, so we'll be using dot all, so that you can just get every predictions there. And then a serializer for this one we'll be using now the prediction history serializer, and of which in the inside will be passing in the predictions, and then also we shall allow many to be true, and then the response. Let me try to just copy this one. Here we are going to return. We shall return response, and then the response there success is going to be true, but then now the count, let me have it here. Count here, it will be the length of the serializer data. That one is going to give us the scalar value of the number of elements that we're having there. And then on the data here, we'll be using now the serializer, serializer.data, serializers.data, and then we actually don't require this one. And then this one we shall return 200 if it's okay. Otherwise, we can use the exception. If, for example, there's an error, then we can catch them in the exception there, where we shall say error maybe failed to retrieve history, and then maybe details. So we're going to use that one. Then here we can return the 500 server error. This is fine. And then maybe we can as well have for the health check, just to see if the APIs are connected to the front end successfully. So again, we're going to use the API view. Then still this will be a get, and then the function, it will be health underscore check. Health check is a function, so we'll be receiving requests from the client side, requests, and then here we shall just return the response. This one will just be returning the response. Let me just use this one. This one, there's not much here. We just want to return the response to tell the client side that it's working. So status, if it's connected well, so status, it will be healthy. Status is healthy, and then a service here we can use maybe a house prediction API, and then maybe some let's say model underscore loaded. We shall use it from the model underscore service. No, it is ML service dot underscore model is not none. It's not none, which means it's there. Yes. So actually, I think we are good with the API's endpoint, so we can register them on the URL. So we can create a URL file. Let me first of all try to. So in the prediction app, I'm going to create a file here called URLs.py, and then here, of course, we will require to have from Django.urls. We are going to, from Django URLs, we are going to import path, and then also from the current directory views, from the current directory, and then the views files. We're going to from the current directory, we are going to import views, but then now this one will require us to be writing the view names before we use it. Or maybe what I will do, let's say from the current directory dot views import the predict price. There was also a model info method, and then there was also the prediction history view, and then the one that we just completed is the health check view, and then we can use the URL pattern. Then here will be passing their path. Now this path will be the first one for the predict, which I'll just say predict. The endpoint will be predict, then the /, and then now the view function here, it will be predict price. It's going to call the predict price, and then maybe the name will be predict underscore price. Then let me find for all of them. I think that there are 4 remaining. 1, 2, 3. There should be 4. So the other one is a model info. Model info, or model info. Yeah, model info. And then this one we can use model info, and then this one should be now for the other one is for prediction history. Let me just call it history, and then this will be prediction history, and then the last wait, okay, yeah, so prediction history, and then we have the health. For the health check, then you call it health, and then here we're going to use the health check. So we don't require this one, they are over. And then so this URL will need to link it to the project. We will need to link it to the project. We need to first of all, remember the work of the URLs is just to map the URLs to the view function, such that when you'll be making a request via that endpoint, then it's going to trigger the specific view, for example, predictive view. Then now the predictive view is going to handle the requested function that it was supposed to do. Like for example, this one to predict, then it's going to handle that. So that's the work of the URLs in this one. And then now on the config here on this URL, so we need to include also add include, and then here we can say maybe path and then this one is going to begin with the API. So for the endpoint, it's going to start with the API /, and then this one we're going to include now that app URL. So we're going to say include, and then here we shall include that app name, which is predictions.urls. So when you do it this way, it means that everything has been configured successfully. So let's try to make migration. To make migrations, like you're trying to create a file, maybe to just tell Django that there are new models you've created, you want them to be integrated, to be applied. So what I'll do here, I'll just navigate to backend, then env /scripts /activate to activate the virtual environment, activate, and then remember it changes. If you are on Mac, it could be something else. Now I want us to make migration, so I'll use Python manage.py make migration, so that we may be able to see if there's somewhere there's an error, so that we can be able to fix it. Yeah, so we are getting these errors. Dot render us. Oh, it should be S. There should be an S. Sorry, render us. Then we're using the JSON renderer. For the parsers, I think this is fine. Now let's try again. Yeah, so it is telling us there's no module named pandas. So let's try to install pandas in NumPy. So pap install pandas. We shall also import NumPy. NumPy, is it installed? Let me go to this ML service. Actually, it's just an pandas, but then let's also have NumPy just in case. Though I know it's also going to give an error. All right, so I see it is installed. Sorry, it is installed, so we can freeze it. So pap freeze to requirements. I want to freeze it to requirements .txt, freeze to requirements.txt to txt, and then now we have NumPy. Let's try it again to make a migration. I know it's going to ask us on the scikit-learn. It's going to really ask us. I just know that. Maybe if not, okay. So basically, there's an issue on the model service. There's an issue on the model service. Let's try to check. It should be on the prediction app, on the ML service. Now on the ML service, we were load models. I think this should be models. I forgot. So this one can use it. Let's try again and see if it's going. We're going to get us another error. So the API view, we are getting the error maybe on which function, on which let me see the API view. The gate should be inside the. It should be inside the. It should be inside the as a list. Sorry, it should be as a list. Let me find it. This one is fine. This one is fine. Yeah, this one, it needs to be inside a list. It should be inside a list. And then let's see any other. Yeah, so that's fine. Then let's try again. We see if there's another error. And then configure has no attribute 4 of 4. Let's see where specifically on which views. First of all, let me try to install the scikit-learn library. So it is a pip install scikit-learn. All right, so this is installed, the scikit-learn library. So let's try to run again so that you can debug the other issue. Now I'll need to freeze it first. We said that I will need to always be doing that. And then we can try to make migrations so that we see the other error that we're going to get here. I think there's an issue on the views. I just want to get that error very well so that we know where to debug from. So guys, basically for this R squared score, first of all, let me try to open this to see if it is in the metadata. Let me just go to let me go there and then see if we had sent it in the metadata. Let me scroll down. Metadata. Okay. Yeah, so we forgot to add in the R-squared score for the training set. So we'll actually need to have that test R-squared score. R-squared. So this one, it will be test R-squared. R-squared. Now this should be even begin. This should, oh no, there's no problem. Now I think I will need to rerun everything. Let me run all the cell. Yeah, so I think it has already completed to run everything. So again, we are going to be required to update. Let's try to update. We are going to update. So from this model to this one, I'm going to just delete everything, and then I'm going to upload the latest ones. So I'm going to copy this one also, this one, and this one. For them, I'm going to copy them. Then I'm going to give them on this ML folder. Right, so then I'm going to try again. I had forgotten that R-squared score. Let's try to run. So what I'm going to do is to try to make migrations again. All right, it has finally accepted. This is wonderful. Then once we make migration, then we can migrate now. Migrate. But then let's just confirm the endpoints if they are okay. Let's just confirm their endpoints if they are okay. So in the views, let's see the predict price. Predicted, let me use predicted here. Let me just use the predicted here. And then we'll change also on the URLs in a short while. And then let me see these endpoints if they are okay. Model info is fine. This should be health. This should be health. The typos, small typos there. And then we will need to remove. We will need to adjust the URLs as well to be health. Predicted. Predicted price. And then this will be now health. Health check. Also here should be predicted. The predicted price. Yeah. So yeah. So so this is really fine. And then also on the models, let me just confirm if everything is really okay. Let's see. Let me see. I think everything is fine. Everything is fine. Then maybe on the serializers, mhm, on the square feet. Oh, square feet, maybe we can be able to increase maybe to some big numbers there. Yeah, so now I think we have, let me migrate. Let me try again to make migration just to confirm if everything is still intact. I'll run this one. No changes. The score it is 91, so it means that it's fine. It has loaded that thing very well. And then also for migrate, there's nothing to migrate. Yeah, this is really amazing. So guys, it means the backend is really functioning very well. And then what we are going to do just maybe to test some few endpoints, or rather, instead of that to waste time on the testing, let's try to just implement the front end so that we can test directly via the front end instead of like also going to waste time on the postman, but then you can as well test it on the postman. So guys, because the video is getting long, I think for the front end, I've tried to take another approach where I have configured everything, then I'll just be explaining. Like instead of doing everything again from the scratch, like typing and then explaining and all that, it can take even more time. So, but then the front end is not much hard. Especially if you've learned some React. Remember, there's a course on React on this YouTube channel. If you haven't watched, you can go and watch, learn more about React, especially the hooks and also the context. You can learn more about that. But then how to create a React app, you can just go to the official Tailwind website, which it is here. But then they have given us like the Google this search has given us some kind of a summary. So if you want to install, you'll say npm create avite at latest. So you type these commands on your CLI, and then the next thing you'll need to install the dependencies. You'll need to navigate first of all to that project you've created, and then you need to install this, you need to run this command, which is going to install the tailwind CSS, post CSS, and auto prefixer. And then you need to initialize a tailwind on the CLI. And then you can go to the tailwind.config file, and then you'll paste this command. And then CSS is just upload this code there, the index.css. This one is just enough, and then you run the dev, then you'll be good to go. You'll have the tailwind working on your system. Now that's what I did, but then now because of time, I'm going to just explain. Now on this src folder, I have the folder for components, where I have three files: model info using the Pascal case convention, model info.jsx, and then I have also the prediction form.jsx, and then the prediction result.jsx, and then I have linked everything on this app.js. I'm going to walk you through in a moment, and then I will have the services. So for the services in the API.js, so this is where all the API endpoints have been configured to make the calls in the backend. So like these apps, these components, I will just be calling the relevant function on the API.js, and then it will be making the calls in the backend using the Axios. Now for the Axios, you will need to install using this command, npm install or I, and then Axios. And then another thing that we are going to use here, it is the React icons. These React icons. So you need as well to have it. First of all, let me Axios, and then the React icon. And remember, first of all, before you install these other ones, you need to just run npm install. Like once you've created the React app, like the way we were guided here, just install, navigate to that project, then run npm install, and then do the other steps, including installing these other dependencies in the Axios. This to make the client set requests, and then this React icon is what I used on these. I used on these components for the icons. and then I click on enter, then it's going to install these dependencies. Now, basically in the backend, a backend will be running on the backend will be running on port 8000. Let me try to navigate the cd a backend, then a env /scripts /activate cls, and then when you run this python manage.py, so by default it's going to use port 8000, but you can always change the ports, but the one that I've configured for the front end is 8000. So the IP address for the local host, it is I should have said python manage.py run server, run server. Sometimes when I talk and type, I usually, sometimes get confused on such. So python manage.py run server, and then you'll see it's going to use these ports 8000 by default. Actually, by default, it's going to use that port 8000. That's the reason I typed there instead of typing the run server. Yes, so as you can see, it is 127.0. So on this front end, on the front end, where is the front end? In the front end, first of all, I don't know why these files have come here. Oh, okay, it's because I'm trying to install these ones under the, I should have used now the, I should have used, you might make sure that you have navigated first of all to the front end, cd front end, and then this is where once you have navigated, like how you are instructed here, you need to navigate first and then install, and then once you have install also this other one, and then I initialize. Once you've done so, then also come and install these Axios and the direct icons. Now on these Axios, I have it on the services API file. So here at the top, you need to import Axios from the Axios, and then I'm trying to create a variable for the base URL, of which we're using this backend address, IP address, which is running on port 8000. But then when you go again to the backend and then to this config, the URLs where we have mapped our prediction, we link our predictions up, it is defaulted to API, so it will be starting with API before any other thing. So as well, I've decided to also configure there so it can be there as by default, like at this address endpoint and then /API, so that it can be there just by default. And then on these Axios, to create the instance of the Axios, I have created the instance with the default parameters. And the first one is for the base URL, which means that the endpoints, we are going to just use this base URL, and then it will just be extended, maybe a /health, a health check, /predict, or something like that, as you are going to see in a moment. So on this, I created the variable called the API client, and then I used Axios.create as a function, and then said I pass my dictionary with the key value pair. The first one is at the base URL of which I used this one. So like I can have its default on instantiation, and then also on the headers by default you're going to use this content type application JSON, and also I have the timeout. So these are the default configuration that the Axios is going to be created with. Now the timeout is in the event, for example, you're making the request and then it's taking long. So it should time out so that it can allow other processes to happen, or maybe give you an error so that you can know what to do next. Now on this API now, on the API, this API variable here, and basically I'm defining now my objects like a kind of a dictionary, and then this one I'm trying to pass in my endpoints, and I'm using the asynchronous. I'm making the calls asynchronously, and that's why I have this one. So this health check, and then with the help of the arrow functions, I'm able to directly make the calls using the async. And then now whenever you're going to use an async, you want to make sure that the calls goes as await. Anytime you're using async, make sure that you have await, and then this one will be calling this API client, of which it has like the default configuration, and then now .get. So on the head, okay, like for the endpoint, will just be saying, for example, health. So it's going to extend from this one API, then /health, and then you want to make sure that it has the is it leading or trailing, slash like that. And then you will be storing those responses. Remember, this is a GET request, so we'll be storing the responses or maybe the backend response in the response variable, and then I will be returning the data to the user. From the response, we'll be returning out the data. The when there's an error, will be caching the error, and then dynamically display the errors, of which you have the handle error here at the bottom. Here at the bottom, I have implemented the handle error function, which is using the error function, where it is handling different cases of the response from the backend on the error. Now, if there's an error response from the backend, then we are going to dynamically display those errors from the backend with several fallbacks. Now, if the backend does not return any response, we're using now the else if, and then if there's no if there's no response from the backend, but then the requests were made, then we're trying to kind of write our own message or maybe response, and then in the event, even maybe the error in the request setup, like the payload, or maybe the kind of data you're trying to send to the backend, it has the issue, then as well we are capturing it on this else. So this is the handle error that's going to do that. And then the other one is the function to get the model info, and then this is the endpoint that's going to call it, which we implemented here on the backend prediction URL. Made info is going to call this model info, of which when you go to the views, this is the logic for the model info, of which is going to just call that from the machine learning is going to call the model info, which we implemented. The other side on the this get model information, these parameters. So this is what we are doing as well. It's a get request. We're storing the backend response in a variable response. Then I'll be returning the response to the client with the data. And then when there's an error, then I'll be calling that function to capture the error and display it. And then for the predict, this one is a post request, which means we're trying to send the those prediction to the like we'll be providing the data, and the client will be providing the data to be sent in the backend to make the request, to make the prediction. So the kind of request is a post request, and still we are using this async. Now when you'll be sending this post request, you need also to provide the values that you are going to send with on that URL, on that connection or communication. So we are sending the post request through the endpoint, this endpoint, and then alongside the data, which it is the house data, which will be getting it from the client side in the form, and then I will be storing the response in the variable response, and then displaying the maybe render the details of this response data, so that the people can be able to see the responses and stuff. Then also for the prediction history, again, this is a get request, and we have the limitation, like kind of a limit, so that it doesn't return everything. I've limited it to 10. So on the get request here, I'm dynamically using the this, like when you use now the backticks, it allows you to use the variable inside the string, of which the purpose was to add in this limit here, a limit here so that it can dynamically limit the history to be returned, you know, and then I'll be saving those response in the variable response and then returning to the user. Yes, this data, of course, we shall be able to display it very well in the client side. So this is what is really happening on this API.js is actually to make the API request through the Axios library. Now, on the components, we have the model info. Basically, on the model info, this is just to get more information about the model. Remember, it is calling this endpoint model info, of which in the model info, it is as well calling or utilizing the ML service get model info, of which it is on this other side is going to return the model name, the test R squared score, the test root mean squared error, the test mean absolute error, then the training sample, the features and all that. So basically on the model info, we are beginning by, first of all, we are going to use now the use effect to make the call, that is to make the call, and then the use effect to make the call, and then the use state for the hook for the states management, which we are doing it here. So you need to import these two, and then also this icon. So we're going to import because we're going to use it in a moment. There at the bottom, and then this is for the API services. So this is for this is a functional based component. So the model info is like the function, the arrow function, and then here these are the states, the before states, and then the state after it has updated, after the information has been loaded. Is going to use now the set info is going to update. So the initial state and the model info is going to be none, and then on the loading state as well, before and after, before and after, and then now for the side effect is going to use this is going to call this a fetch model info, and of which the fetch model info it is here, of which is going to call the get model info. This one is going to make to call this when you run this like at the browser, this use effect is going to make a request through the endpoint we implemented the other side get model info, and then it will be updating the set model info, which was initially without the data null. Now it will be having the new data here. Then when there's an error, then it's going to capture the error, and then now we can log the errors in the console. And then if it has already logged the error and it has mounted everything, then I shall update now the loading from loading to false. Remember, by default, it should be loading, but then once this content has been mounted and everything is there, we are turning it to false. And then this is some logic, like a loading kind of a UI for the loading. So if you wish to use the same, you can be able to just pause the video and then use the same configuration. Yeah, so basically on this one we are having in the return statement, this one we're trying to just display some model performance stats. So this is some kind of the header, and then basically on the algorithm, we are displaying the kind of the algorithm that has been used, of which the front end is, the back end is returning the model info, the model name, for which we know it was the linear regression model. And then for the accuracy or R squared, is going to calculate it, but then now it should turn it to a percentage. So we use now the R squared score multiplied by 100, then we use here to fix to 1, so that you can display now in the percentage with at least one decimal place there. Now the same case to the root mean squared error as well, we're displaying it there, and also the training set as well, we're using now the model info dot training sample also on the same, and then also the input feature. Remember, this is like the features that have been used to train the model, of which we also return in the backend as well, because there are several of them. We'll need to use we need to iterate over them. That's why we're having here the map, and then we'll be having the several of them. So we need to iterate over it. If you wish to use the same logic that I've used, then you can as well do that. And then this is on the model info. And then for the prediction form, still we're importing this hook React, and then also there's a several bunch of icons. If you wish to use the same UI, you can import it. And then also this from the far React icon, like it has several sub libraries. So we have the FA, then we also have the MD. So for the MD, we're trying to import this MD layer. Then of course the API service, which was exported the other side. It was exported here at the bottom, export default API. So as well, it's a functional based component where here we are trying to use the we are trying to use the props here on prediction complete. We're trying to use this prop for which it was passed. From the other side, we are going to also check on that. So once you have this prop, then the other thing we are trying to implement the hook for the loading, and then for the form data, we shall initialize it with some default values so that someone can start, just click on it and then make the call. So something like a template to know what they're going to just update and then use it. So for the form data, and then now have the set form data if the user has updated the form, and then that's what it's going to do. And then I have this the handle change in the event, for example, the user tries to update it with some new value. Then this handle change function is going to track that, and then is going to save those changes. And then on the submit function here, basically here when you're trying to submit, I will be setting it to load and throw, and then this call that we'll be making, remember, is a post request. So the other side we implemented it is a post request, and then we'll be having the results. When there's an error, then I shall alert the error, and then I shall stop the loading. The loading, if like the data wasn't success, if the error has been shown, when there's an error, then we will stop now the loading and then display appropriate messages. Then what if you wanted to reset the form? We have a button for that. So for that one, when you reset the form, then it's going to update now the set form data from what was updated using this handle change. Then it's going to return it to its default values. These are the parameters there. If you wish to use the same configs that I've used here, you can pause the video and then I use the same thing. And then on this return statement, this is the header, the property details. And then on this form, on submit, it will be triggering this handle submit, of which we know what's going to be happen on the handle submit, all these logics we implemented when you submit. So on the form, we are beginning the basic info like as the title, and then the first label here it will be for the square feet. So people will be keying the square feet in this input, and then the value here it will be form data dot square feet, and then on change, then the handle change is going to update it, and then we've given some basic styling on the forms. If you wish to use the same, you can pause the video and then copy the same configuration there from this other side all the way to this at the end, the tailwind CSS. I'm not going to explain each and every styling because of time and all that. And then we are making it also a required field. Now the same case to the bedroom, the same case to the, let me try to zoom out so that you guys can be able to see very well. The event, for example, you are copying the UI. So this is for the bathrooms. So the same configuration actually. And then for the edge years as well, the form configuration. the same configuration. Actually, what you just need to be sure that you're using the numbers, because and the other side we say that they are integer fields, so most of them, and then also for the garage, also the same configuration. The same case to the square feet. This one is also the same configuration. Now remember the lot says square feet. It should match with what you shared there at the top, so that it can match with what the backend will be receiving. And then also for the floors as well, the same configuration. Now on the crime rate, this is a float. This is like a float, and the good thing is that you're able to extend to increase with some values there. So the step here we're using now 0.1, and then as well the same configuration we used the other time, but then you can give it a mean, which is 0, max was 20, to align with what the backend provided. Remember, on these other ends, we're also using those default values, mean and their max. These are the values. Actually, the same configuration, guys. And then for the, what is it? For the school rating score, 1 to 10. And then for the distance, this was a float as well. And then for the neighborhood, the rating is 1 to 5, the same configuration, guys. And then for the amenities, remember these are the booleans. Either it has a pool where we are using 0, 1 if there's a pool, then if not, we are using a 1. So the input, now this step will be a checkbox where a check, when you check it, is going to be 1. If it has no pool, then it's going to use 0. So it's going to be defaulted to have, and then like what we shared in the form data, and then for the fireplace as well, the same configuration here, and then if it was renovated, the same configuration, and then this now the action button, like the submit button. This is what is going to happen in like when you're trying to submit on loading, it's going to kind of display something, some good UI for showing the loading, maybe calculating like during the calculation process, or maybe sending those requests to the backend is going to display something. Otherwise, if you haven't submitted, it will say predict price, and then there's also a button for resetting, and we implemented the function for that, for resetting, and then yeah, so that's it for this form. Now if you wish to use the same config, then let me scroll slowly so that you can be able to see it. Let me just scroll slowly from this part. You can pause the video and then check the same configuration. As well, these are the part if you wish to use the same configuration. I've zoomed out so that you can be able to see this long styling. The same case here. I will not explain, like if I would say to go and explain what the border does, what the border gray does, rounded MD and all that, it's going to take a lot of time. So just pause the video, and then if you wish to use the same UI, you can do that. And also another thing, this UI, provided you have configured the backend very well, this UI you can even use the ChatGPT to generate for you the UI. It's not that complicated, but then at least try to know what maybe the logic that is happening, especially in terms of making the calls in the backend. And then this other end is going to be just easier. It's going to just be easier. So actually I'm doing this so that you can be pausing the video, copy the same configs, or maybe styling, so that we can be able to, if you wish to use the same UI, but a lot of work is on the backend. And then I make sure that at the end of it, you're exporting each component, like what we did the other side. Also on the model info, we did that we exported the component. Others you'll not be able to import somewhere else, so make sure that you have exported. And then also on the prediction result, guys, this one is just to display now the currencies. So prediction results now, not the currents actually, like at the kind of a score the model has given you. So first of all, you need to have React, even though it's not going to be used there. Just to know that this component is a React component, you just need to have the React there at the top, even if it's not going to be used anywhere. Just know that behind the scene is going to decorate this file so that it's going to be known to be a React component. Then these are the icons. Then these are the checks if it is null on this prop. Then these are the for the results. Okay, like actually for the data, we're storing them from these results of which from the prop, and then for the price again we're extracting that one. And then now there is this advantage of this the props. You can be able to reuse them. These are like variables. Then I will have here a method or a function for handling the price. By default here we're using the US currency for this system, and then also the confidence score to be now that confidence multiplied by 100, so it can change it to a percentage. Then we use now to fix to one, at least one decimal place. And then now this is the header. This is the header. This is the header, and then now the predicted price. We'll be using now that formatted the formatted price, as well on the model info, on the model information header. These are the details there. A machine learning algorithm. Here, first of all, the name will be getting from the data model name, and then for the confidence, we'll be using that one in percentage, which we converted to the percentage here. But then you are adding just that percent, so it can show some percentage. And then for the feature summary. As well on this other one will be displaying, for example, in terms of the the square feet, the property summary, like how many, because that was like the key feature that was contributing to, or maybe the one that had like a highest correlation. So for the square feet, and then maybe the number of bedrooms, the number of bathrooms, the edges, and those are the key, those are the top features that determines the pricing, or they had the strong correlations. And then at least you need to give people some disclaimer that prediction are estimates based on historical data. Actual price may vary based on market condition and property specifics. Remember, on these AIs, you need to give warning so that people will not fully just rely on that. Like sometimes the AI can make mistake because these things are trained. So you can have the issues. So you need to give some kind of a disclaimer so that someone will be able to know, or maybe just know that this AI is just used to help trying to automate stuff, but then it's not something that is kind of final or something. Just like based on the historical data, it's trying to provide some kind of a solution, but then it's not like something that you will really rely fully on it. You can go to the real homeowners and then now ask the questions there about, for example, the pricing and all that. They can give you proper detail. Sometimes there are some other real estate agents, or maybe the house owners. They can just give you the price depending on how your status is. So for example, if you're wealthy, you see that they are going to give you a particular a price. If you are poor, there's how they can as well give you, or maybe like your price will vary, or depend on how you're going to negotiate and stuff. Now on this app.js, so here's where I'm going to import everything. First of all, we need to have these hooks. We need to have the these icons, basically for home, and then also for the prediction form components from the components folder which we have implemented. We need to have them all those components we need to have, and also the API call, because we'll have the header which is going to show the server health status. So first of all, here at the top on this app, like at the main application here, we have these two sets, use states. The first one is for the prediction result, of which is not going to show anything by default, but then later it's going to set prediction results, and then also for the server status. Then the server status after it has been updated. Then there's a use effect here to make the to check on the server health as well, which we have implemented here. When you run this use effect, then it's going to call this method, this function, and then this function is going to call the health check endpoint, and then it's going to return the response, of which is going to be rendered by this use effect. And then in the event, for example, the server is not configured very well, or maybe there's an error, then we'll display online. For example, if the request will be successful, then we're going to display it maybe online, something like that. Then also for the handle prediction complete, if the prediction has been completed, and then will be set prediction result, of which is this, like at the prop that we also used the other side. So set prediction result, and then also there's a timeout handling as well here. And there's timeout handling in the event, for example, there's a timeout, and then here basically we're trying to have the header on this return. We are trying to have the header, like that navigation thing there at the top on the header. So this will be the house price predictor, then a machine learning price estimates. Then on this other right hand side, will be displaying the status, if it is online or not online. So if the status will be healthy, of which with these things we implemented earlier in the backend, like at the kind of the responses that's going to be returned on the health check. So if the status is healthy, which means this one is success, then I will be returning this 2000 alongside some the model name will be, if it is healthy, and then it will be green, and then if that the status is healthy, that is, it will show connected, otherwise it will be offline. Like, remember, this is still on the header there, where you have like the logo, or maybe the logo name, or maybe the brand name, and then this other side you have now that status check on the right hand side. Then on the main content here, we are trying to render now the model info. Remember, just a single page, there are no routes, so otherwise you could have imported the routes, and then route for managing the routes to navigate from one page to another, or component to another. But then this one is just one page, and then so we'll be having the model info on the side, and then also here we'll be having the form on the left column. On the left column as well, we'll be having the form, and then on the right column we'll be displaying the results on the large screens. And then these are the stylings that we have implemented for the form. Remember, form we had already implemented. So on this other side, we are displaying the, first of all, we display the form on the left hand side, then the results, it will be now on the right hand side, of which we will just be using that component that we had already implemented for the prediction result. And then the other thing is okay, if you wish to use the same setting, you can use that. Then for the features about the section about, for example, the system, what is all about, or maybe the tool is all about. So there's some brief kind of information there, maybe some kind of a footer, or maybe something at the bottom, so that someone can easily know what the system is all about. And then you can also show tell them the sample size that you've used for the real estate houses, or maybe those houses. Then what the system it does, giving you the prediction in instance, and then it's a data driven based on the comprehensive market analysis. And then now that main footer there, the very last footer, and then maybe you can have the GitHub link. For example, if you want someone to see the source code for the system, including the data sets and all that, you can do that. You want to make sure that you have exported, because this is what this main.js is going to render. Remember, React is a single page application. Yeah, so guys, basically for the front end, I've tried to go faster, sorry. I'll try to go faster because the video is very long already. So I tried to just make it faster, but then now front end is mostly not that hard because it's just consuming what the backend has provided, and we took a lot of time on the backend. So, but also in case there's an error, there's a question or whatever, you are curious about something, you can always ask in the comment section, then I will reach out. So I want to kind of run, and remember I made some change on this byte config. Remember, by default is usually use this 5173. So for me, I added this server, of which by default is going to use this port 3000, and then when you run, it's going to automatically open the browser. So I gave open to true, and then among other, these are the parameters. If you wish to use the same config that I'm using on this byte.config, you can as well do that on this byte config. Yeah, so this is what I've done. So I'm going to just run npm run dev, npm run dev. Then when you run, it's going to automatically open the browser because of this open to true. And then all right, the API is not connected. First of all, guys, you need to have this in the backend. In the backend, you will need to have this cross-origin resource sharing headers from Django. Actually, remember there are many, so you need to make sure that you're going for the Django cross-origin resource sharing headers, this one. And then you want to make sure that you are installing. So in the backend, we are going to install. Let's try to install it. And then once you install, you need to add this cross-origin in the list of installed apps. So config. Then let me find it. List of installed apps. And then of course a comma. Then the other thing was on the middleware here. I see that it should be before the common middleware. So let's have the it should be before the common middleware. Let's see, where is it? Common middleware, or maybe we can even have it maybe after this one. There's no problem, I hope. Oh, sorry. Now I'll need to copy, and then I will paste there, and then you need to have a comma at the end of a list element, and then now we can have these allowed origins. And I remember in the front end we were not explicit on the type of headers that we are sending. Actually, we're just using that application JSON. So basically, maybe here I can have this one. Now remember, the front end is using the ports. Sorry, the front end is using the ports 3000. We changed to 3000. So let's use the alias and the IP address. All of them to be 3000, and then also this we can this one, of course, it should allow these methods by default. Both actually here we'll be using just the post and the get, but let's just have everything there. It's not costly. And then this one you need to have it because of the allow headers. We're using the content type is application JSON, so this is what we are using in the front end. So I believe once we do this, we are good to go. First of all, anytime you're going to install something, make sure that you're freezing on the requirement.txt. So pip the backend freeze freeze then requirements.txt, and then it's going to do that. It's going to freeze, and then now you can see we have the cross origin. And let's try to run the server. Manage.py run server. Yes, and then when you try to reload on this at the end, let's try to reload. Still, it's not making the calls. Let's see. All right, basically it has returned the, oh, it's active with it. It's making the, let me see. Oh, let me see, permission, is this permission issue? Let me see. So we will actually go to the predicted price, and then try to see if there's a bug somewhere, and especially the prediction results. So that's where mostly we are getting those ish. So the so this should be predicted. Sorry, this should be predicted. Predicted price. Predicted price should be, that should be, and also, and then these at the end should be predicted. To avoid the typo, I forgot that one. So predicted, not predict. Let's see if there's any other issue like that. Let's see. Let's try to reload again. Let's see. Prediction failed. You're still getting the same error on this. Let's see on the serializer, especially for prediction response. Features. This should be features used. I hope so. Yeah, features used, and then. Okay, let's try again. To reload. Still. Okay, yeah. Finally, there's prediction. Prediction has been made. This is wonderful. This wonderful, it has been made. But then now on the health check, and there's also an issue. We need to see on the health check endpoint. That should be here at the bottom. It should be healthy. Yeah. Let's try again. Still, oh yeah, it's connected finally. This wonderful, guys, finally we've managed to fix all the bugs. Let's try, for example, 30,000 maybe, 30,000, then maybe to 2-bedroom, maybe bathroom is, for example, 4, and then AGS maybe we use 0, like at the latest. Garage maybe 3, maybe for 5,000, and then floor, for example, 1 or something, let's say 3 or 4, and then let's try to make the prediction. You see, yeah, so it has given us this price. Yeah, so this is, and also it's trying to display the confidence. Now we converted it to the percentage, and then now when I will reset and then try to predict, you can see now it's giving us this value. So anytime you're going to modify, for example, the square feet is, in fact, this is the one that really affects the scores. For example, when you give it a 5,000, I see the price that is, for example, when you give it 6,000, 6,000, you can see this is having like some high impact. For example, something like a bedroom also takes some impact, like maybe the garage or maybe the floors, if I will give it to 1, you'll see that it doesn't have much impact. Garage, for example, if I give it to 1, you can see it has some small impact, but then what it is having some big impact, as we saw when we were training the model, it was on the square feet. Yeah, so guys, as you can see, the system is working all the way from training the models to serving the models and implementing now the backend. We took a lot of time on the backend. Then now the front end, we just made it to feed on what the backend is trying to provide. And finally, guys, we have a working system. Now, don't mind about the UI. This one you can be able to change and all that. But then just see how we're trying to communicate with the backends, and then how the UI you can be able to update and use what you really wish. Now, guys, I remember there's a lot involved in data science, and one video cannot handle all the data science stuff and all that. So I usually teach at a college. In the event, for example, we want to learn matters, data science, machine learning, including also the software engineering stuff. We usually provide those courses. There's number running there at the bottom. In the event, for example, you want to get our advanced data science course with practical and project based, please reach out. In that data science, you'll learn everything regarding data engineering, data analysis, data visualization, machine learning engineering, to model deployment, and everything about the data science pipeline. You can reach out so that we can onboard you on the next cohort. In case you have an issue, please feel free to reach out in the comment section, then I will be able to address it. And also, guys, remember to like, subscribe to the video, and share it to your friends. And also, if you wish to support me, as you can tell, I've talked so much. I don't know how many hours here, but we've spent a lot of time, and also I have a team here. If you wish, for example, to support us, then I will highly appreciate. The number is there at the bottom. We will highly appreciate very, very much. Okay, until next time, this is Nehemiah. Goodbye.